and welcome to the United States Transhumanist Party Virtual Enlightenment Salon of September 27th, 2020. My name is Gennady Stolярov II, and I'm the chairman of the United States Transhumanist Party. Today, we are joined by an esteemed panel of US Transhumanist Party officers, including our secretary, Pavel Ilin, our director of applied innovation, David Shoemaker, our director of visual art, Art Ramon Garcia, our director of community resilience, Alexandria Black, our director of scholarship, Dan Elton, whose involvement made this particular event possible, and of course, our 2020 US presidential candidate, Charlie Kam. And our two special guests for this salon are perhaps the world's leading experts on brain preservation, Dr. Kenneth Hayworth of the Brain Preservation Foundation, and Dr. Robert McIntyre, who is the CEO of Nectome. And today we're going to have a wide-ranging discussion on both the science of brain preservation as well as the objectives that it seeks to accomplish and some of the philosophical questions and implications surrounding those objectives, including the preservation of the self of the individual, what we're trying to achieve with all of these technologies that aim at transcending our mortality and perhaps giving some people the opportunity to continue to exist even if they succumb to physical death at some point in time. So with that, by way of introduction, Dr. Hayworth has prepared a video, the introductory video in an 8-part series about the Brain Preservation Foundation and its mission. And this is a great video to get people familiar with some of the work that Dr. Hayworth has been advancing over the years. So let us play this video right now. And afterward, we will have an introduction by Robert McIntyre as well.
Hello, my name is Ken Hayworth, and I'm the president and co-founder of the Brain Preservation Foundation. The Brain Preservation Foundation, or BPF, is a science advocacy organization. Our mission is to advocate for the development of a medical preservation procedure that can preserve those structural and molecular components of the brain that modern neuroscience thinks encode memory and personality. For example, the synaptic connectivity of the brain, the ultrastructural details of synapses that are correlated with their strengths, and any molecular information like the identities and locations of ion channels and receptor proteins that may also be needed to decode memories.
A reasonable question to ask is, why on earth are you advocating for a medical procedure that admittedly cannot save a terminal patient's life, but instead only gives the patient the option to have their brain preserved in a static state upon their death? Why would any terminal patient be comforted by the idea that their brain's detailed structure will be preserved and stored sitting on a shelf indefinitely, when their brain's biological functioning cannot be preserved? The answer is that brain preservation offers a terminal patient a slim but non-zero chance of revival in the far future. Of course, this is precisely the argument put forward by traditional cryonics. Stabilize the patient in a static state, for example using extreme cold, for however many decades or centuries is needed for humanity to develop a cure to their illness and a way to revive them. Unlike cryonics, however, we fully accept the fact that current science simply is nowhere near close to achieving reversible cryopreservation for humans. Today's attempts at human cryopreservation produce so much damage that any hypothetical future revival would be better viewed as reconstruction from a damaged blueprint. With this unfortunate fact in mind, we believe that the best that can be hoped for today is to develop a procedure designed specifically to preserve those molecular and nanoscale structures of the brain that encode long-term memories, a goal that is within reach today. Let me carefully lay out our reasoning. First of all, modern neuroscience is based on the idea that our conscious thoughts are solely a product of particular types of neuronal computations in our physical brain. Since these computations cease at death, the conscious mind disappears as well. But these computations also cease temporarily during sleep, general anesthesia, and medical procedures like deep hypothermic circulatory arrest. The implication is that there is no continuity of consciousness. We pop out of existence every night and reboot every morning. The illusion of continuity rests in our long-term memories. Our true self is more correctly viewed as being the sum total of our long-term memories, broadly defined to include all of the genetic and learned knowledge in our brain. Death is simply our neuronal computations shutting down for the last time and never rebooting. Brain preservation's goal is to preserve in a static state the neuronal structures that encode a patient's long-term memories, stopping them from being permanently destroyed as the body decays. As long as the patient's unique set of long-term memories is preserved, at least the possibility of rebooting them in the future exists. When we look at the tremendous pace of scientific and technological advancement today, we see every reason to believe that humanity's progress will continue until we, 1, have a comprehensive computational understanding of the brain. 2, have the technology needed to scan a preserved brain's molecular and nanoscale structure in order to decode its long-term memories and function. And 3, have the expertise needed to simulate that brain's computations to control a robotic or virtual body. Now, of course, we fully appreciate how outlandishly difficult it will be to perfect such mind-uploading technology. It may take a century or more to do so. That is why it is essential that brains are preserved in a manner that can remain unchanging for centuries. Now, in the future, simulating a preserved brain would, in effect, reboot the original person's mental computations, along with their long-term memories. It would feel to that uploaded mind like it had reawakened from a long sleep, in the future, in a healthy new robotic or virtual body. From this perspective, it should now be clear why some terminal patients facing certain oblivion today could find this possibility desirable. Of course, many patients would never choose such a brain preservation option for themselves, for religious, social, philosophical, or other reasons. But please understand that some terminal patients would, especially those who, like us, fully accept the neuroscience view that the human mind is computational, and that want to continue their fight for a chance to see the future firsthand.
7 years ago, my organization put out a challenge prize called the Brain Preservation Prize to the cryonics community to challenge them to demonstrate that their methods are able to preserve at least the synaptic connectivity of the brain. This milestone was chosen as a crystal clear concrete milestone that both the cryonics advocates and the cryonics skeptics could understand and accept, to bring them together to work toward a common goal, if you will. Unfortunately, 7 years later, the cryonics community has not yet been able to demonstrate that their methods preserve even the synaptic connectivity of the brain. But we put out this challenge to the larger scientific community as well. And at least one team was able to demonstrate a new technique called aldehyde stabilized cryopreservation that can preserve the synaptic connectivity of the brain and much more. That group was the cryobiology research company 21st Century Medicine and was led by lead researcher Robert McIntyre. They developed a technique which combined glutaraldehyde perfusion fixation, which is something that is very common in neuroscience research, with cryoprotectant and long-term cryostorage of brains. And what they showed is that they could preserve entire rabbit and pig brains using this technique, and using 3D electron microscopy, they could show that they had preserved those brains at the ultrastructural level, preserving the precise synaptic connectivity of those brains. But this procedure did more than preserving the synaptic connectivity, the structure of the brain at the tens of nanometer scale. Because this procedure is based on simple glutaraldehyde perfusion fixation, it also likely preserves the most important sets of biomolecules involved in neuronal computation, ion channels and receptor proteins. Now that the Brain Preservation Prize has been won, BPF is shifting its focus toward engaging more with the neuroscientific, medical, and medical ethics communities, as well as the larger society. To the neuroscience community, we want to ask the following question. Do you think that aldehyde-stabilized cryopreservation is preserving the content of the information content of a brain? If not, what additional molecules and structures need to be preserved in order to do so? There can be no guarantee that any preservation technique is sufficient, but what we are asking is, given our current models of memory, of how memory is stored in the brain, does ASC preservation seem sufficient? And if not, what is missing and what might be done to correct this? To the medical community, we want to issue a challenge to develop the ASC procedure, or something better, into a full medical procedure that could be applied reliably in hospitals to terminally ill patients. To the medical ethics community, we understand that the idea of brain preservation is very different from any other medical procedure that is existing today. And we want to ask you, is there any framework that would allow brain preservation to be applied to terminally ill patients that choose this for themselves in an ethical manner? A framework that ensures that each patient has truly given informed consent and has a full understanding of the speculative nature of the endeavor. And our challenge to the larger society is to simply try to envision a world in which affordable, reliable brain preservation is the right of all people and is available in every hospital in the world to every patient facing a terminal illness.
All right. Well, that was an excellent introduction to the prospect of human brain preservation and the current thinking behind it. So thank you to Dr. Hayworth for sharing this video with us. And next we will go to Dr. Robert McIntyre for his introductory remarks. He recently, in February, gave a presentation to the Long Now Foundation, and we asked him to summarize some of the key ideas from that presentation.
Well, thank you. It's a pleasure to be here and a pleasure to talk to such a wonderful audience. So I would say a good way to think about this is in comparison to the preservation of DNA. So the question is, when did we first understand that we could preserve DNA in a way that could actually preserve the hereditary information of a species for a long period of time? And although we've only recently begun to be able to read DNA, I would say that the first time at which we were able to, with quite a large amount of certainty, preserve DNA was in the late 1950s or early 1960s, when we discovered what the structure of DNA is. So a whole half century before we were able to scan DNA, we were able to preserve DNA. Any real good biochemist could have told you, once we understood the structure of DNA, any number of preservation techniques would be able to preserve it, such as cooling or various chemical preservation means. And you might say, well, why would we want to preserve DNA in the late 50s if there's nothing you can do with it? And the idea is that, well, since nature is able to scan DNA, clearly it's possible to do. And so one day we would probably also gain mastery over similar techniques and be able to scan DNA. In the meantime, we have a species in the late 50s that's about to go extinct. So what do? Do you let that information be destroyed? Or do you speculatively preserve that information and keep it preserved in the hopes you'll eventually be able to read it? The really interesting thing about this is we barely had an understanding of what DNA means in the late 50s in terms of being able to understand really anything about genetics, how a protein is made, how what any of these types of symbols mean. We knew very little bit about that. All we knew was what the building blocks were, but we knew a great deal about the chemistry of the individual building blocks, and so we knew enough to preserve it. You can be able to preserve something without being able to really understand it hardly at all. Same thing goes with other types of information storing artifacts. If you have a book that's written in a foreign language, it's very easy to preserve that book, but it may be a lifetime to learn enough to be able to read that book. So, what we actually did as a species, towards the end of the 60s was some people created this thing called the San Diego Frozen Zoo. And they preserved DNA of species that were about to go extinct, even though there was nothing you could do with it at the time, because they thought that eventually we'd be able to read them. At the time, in the 1960s, if you wanted to read DNA, not that we could do it, but if you wanted to estimate how much it might cost, it might be $1 trillion, given the speed of the technologies that we had that could read a tiny little bit of DNA. Today, it's about $1,000 to read an entire genome. So it's now economical to begin to read some of these preserved samples. Currently, DARPA has a contest to scan an entire genome in less than an hour for less than $1. And there's many competitors for this contest that think they're going to win that within the next 5 years. So you can preserve things a lot sooner than you might imagine. And it's generally true for a lot of things. And I think that is true for long-term memory, the information stored in neural tissue today. Do we understand at a systems level how the brain works? Meaning, how does the basic molecular and structural modifications of a brain give rise to behaviors, or how particularly is information encoded? I'd say we have a very poor grasp of that right now. It's akin to understanding the structural organization of DNA and how it gives rise to a body. But on the other hand, we have many decades of advanced molecular neuroscience and structural neuroscience, and we do understand the types of physical changes that have to occur in a brain to encode a memory. And we understand that if those don't occur or they're disrupted, then the memory is not encoded. So we understand the building blocks of memory. And we understand what they're made of chemically, we understand what they're made of structurally at a basic nanoscale and cellular level. And that's all you need to be able to preserve it. We also have this incredibly sophisticated chemical preservation technology based on glutaraldehyde that can bind proteins together, can bind structure together. And it's a truly phenomenal preservation technology. Glutaraldehyde is a low molecular weight molecule that has 2 aldehyde ends, and it kind of works like molecular handcuffs, grabs onto proteins, binds them together into a gel. And it essentially archives all proteins in a biological system and preserves all nanostructural cellular details. Those images that you were seeing earlier in the video are from pig brains preserved with glutaraldehyde. And for any individual synapse in a brain, you would be able to find that synapse again after preservation with glutaraldehyde. And the ion channels in that synapse would be preserved. Essentially, all the proteins in that synapse would be preserved. And of course, the physical size and structure would be preserved. So one way of thinking of a brain is as a collection of a quadrillion synapses, which are each individually little kind of like switches that can change their size and encode information. And so glutaraldehyde is able to preserve all of those. Another way of thinking about preservation in a more information theoretic term is what physical changes would have to occur in my brain to encode one memory. right? What's the difference between, I know that it's called, well, okay, let's say, I know that his name is Ken Hayworth, right? But his name could have been Bob Hayworth, right? So, what's the difference between that memory? And we know from neuroscience that involves thousands and thousands and thousands of synapses that have to change between those two hypothetical versions of me, one which knows Ken Hayworth, one which knows Bob Hayworth. And the question is, how fine a preservation are we able to achieve? If you use glutaraldehyde to preserve a brain, if you imagine two different brains where there's just one single synapse between them, you've deleted a single synapse, would you still maintain even such a subtle difference? And the answer is yes. That's the type of thing that we know today. And I think that it justifies designing a brain preservation protocol, and it justifies working towards creating a medical technique to preserve individuals that understand these things, even though we're very far away from being able to actually interpret this. After all, the brain itself can read its own memories in milliseconds. So there clearly is an efficient way to take a neural network like the brain and read information back out of it. So yeah, that's the general idea behind this.
Well, thank you, Robert, for that overview. We definitely appreciate your efforts and Dr. Hayworth's efforts as well in developing our understanding of how to preserve the structures of the brain, notwithstanding, of course, the limitations we currently have for reading the memories from those structures. But I wonder, in the future, let's say we travel 150 years from now or 200 years from now, or however long it will take, do you believe that these particular methods of preservation that you use with glutaraldehyde will be able to be reversible, in the sense that you could take the same brain and essentially withdraw the glutaraldehyde somehow and then get functioning synapses again? Or is some sort of different approach going to be necessary, like the approach that was discussed of essentially scanning and uploading the brain?
Well, figuring out what future technology looks like from today is sort of like sitting in the 1900s and trying to figure out what the technology of today would look like. So you're going to make a lot of mistakes. I remember people thought we'd have like central kitchens, right? And we'd have vast pipes, like pressurized pipes that would send food out to a whole city. So anything I say is probably going to be at least that wrong in terms of what this will actually look like. In theory, could you somehow like undo glutaraldehyde fixation? I mean, sure, right? You can undo the chemical crosslinks. Such a procedure would be such a comprehensive thing that it would almost be like rebuilding the fixed structure in place. So I think that it's more an issue of like economics as well. Like, what are the technologies that will have been validated on animals in the future, right? What will be cheapest? If you're trying to figure out how are we going to scan DNA in the future, you probably wouldn't necessarily do it the way that we do it today, right? Or envision that. So what I think is probably the most likely path is that the electron microscopy technologies that we already have today, or the other nanoscale imaging technologies that we have today, will get better, and they'll get faster, and they'll get cheaper. And that will, over the next 100 years, do things like upload a fruit fly brain, right? And then we'll scan an entire mouse connectome, and then we'll upload a mouse connectome, and then we'll upload animal brains, right? And we'll scan entire animal brains, and we will work out a lot of the kinks for doing this procedure, and it'll have been validated on animal models for decades. One thing that is a common flaw in estimating the future is imagining that we'll go from sort of like we are now to having this technology that can scan human brains. But of course, you get every single other brain that's smaller than a human brain along the way, and you've got a lot of time to validate that. So if you're even considering uploading a human brain, you would have already had a lot of experience uploading dog brains, uploading monkey brains, right? And you would have seen that that technology works perfectly for those types of animals, or you wouldn't be considering doing it on a human. So that would be one of the context. And then if you're talking about a preserved brain, whatever the technology would be, it would have already been validated on contemporary people in the future that have a full understanding of the technology and can give full informed consent to whatever that technology is. And that would have been done thousands of times. You don't take your precious DNA sample from the San Diego Frozen Zoo and use some prototype shabby little device to try and scan it, right? Use your 5th generation Illumina device where you have a contract with that company that if they screw up the scanning, you can sue them, right? And they'll guarantee you a certain level of quality. If you have a preserved brain, you don't use some prototype uploading technology on it. You use something that's been validated on animals and that's been validated on thousands or hundreds of thousands of contemporary humans in the future to the point where it's routine. So while I might not be able to say the exact technology, that is what I would expect from a responsible type of technology in the future. And then the question is, even philosophically, right? Like, if we have a hard time thinking about these things right now, but if you've had a tradition of doing this on animals for decades, right, and it's sort of old news, I think the philosophy makes a lot more sense, to the point where you could almost use whatever the opinion of the future is as a surrogate for good informed consent today. Does that make sense?
Yes, and that's quite a helpful answer. And indeed, technology evolves incrementally, and from our current vantage point, it would be difficult to see all the steps in that evolution. But I agree that generally speaking, humans tend to gradually apply these kinds of technologies, and they don't go into human experiments right away. So I agree that some sort of trajectory of application to simpler animals, progressively more complex animals, will ensue. Now, I would be curious to hear Ken Hayworth's perspective on this as well.
Yeah, well, I definitely agree with what Robert just said. I think that what I would add is nobody in their right mind 150 years from now would, even if they could, undo the glutaraldehyde bonds and reconstruct at the molecular nanoscale level what amounts to a Model T Ford. What you would be giving up is you'd be giving up all of the advantages of having your mind uploaded into a more robust technological form.
Yes, thank you, Ken. And Dan Elton has an interesting question that we'll follow up with. He's curious about what the technical issues with present-day cryonic preservation are from your perspective. And I'll add another component to this question, because in one of your videos, Ken, you mentioned that somebody undergoing brain preservation, even using this glutaraldehyde fixation method, will likely get their entire body preserved as well, just because it's easier to do that. And that seems to me to be compatible with a full body cryopreservation. If you take that body then and you put it into a cryogenic tank at very low temperatures, do you think that could be an improved cryopreservation technique compared to the vitrification that's used today?
Sorry, is this for Ken or for me?
For both. Just select which one of you will go first.
Okay, you go for it, Ken.
Okay, great, thanks. So I think something to consider here is basically the cryonics community has tied their hands behind their back to a certain extent by wanting to hold on to the idea that you might be revived biologically, whatever that means, because like I think Robert was talking about, the idea of having nanotechnology come and repair cryonics damage is really equivalent. I said this in the video. It's equivalent to repairing somebody from a damaged blueprint. So it's already, you're creating a copy essentially. And so the cryonics community has essentially said, we will not use the fixation technology that the neuroscience community has been using for the last 5 decades to preserve brains properly. And we think I think that is a just tremendously backward way of thinking. None of our technology is able to preserve a person so that they can be simply revived. The best that we can do is to preserve the information content of the person's brain and peripheral nervous system, et cetera. And it is absolutely clear that that if you include fixation, that you end up with a much more robust. And I want to describe why that's the case, and Robert can definitely go into more details on this. But in a regular cryonics procedure, you are racing against time. You are trying to lower the temperature of the body as fast as you can, but you have to get a high quantity of cryoprotectant agent in so that you prevent ice crystals from forming as you lower the temperature. And so, if you're stuck with that type of procedure, you're dragging out a procedure over hours, where the molecular structure of the brain is really self-destructing at one level or another. If you compare that to what glutaraldehyde does, it within less than a minute comes in and basically eliminates the metabolic processes in all of the cells. It stabilizes everything and it glues everything, it glues all the proteins together. And at that point, you can take your time to get the cryoprotectant concentration up in all of the cells and across the entire brain. And that's really, if you take away that ability, then you're going to get very bad results. And I think the challenge is still out to the cryonics community. Show the world in a peer-reviewed publication what quality you can achieve for preserving the structure of the brain using your current techniques. They haven't done that because I'm pretty sure that they look absolutely crappy. And every time that I've looked at one of these at a kind of cryonic-like preservations, I see. If I show this to my neuroscience colleagues laugh when I show them it. Unlike when I show the aldehyde stabilized cryopreservation technique, the samples from that, which won the prize, the technique that Robert developed, they cannot tell the difference between that and textbook pictures. They cannot tell the difference between that and the best quality tissue that they produce in their own labs for studying memory of all things. In any case, I think I've beat that horse.
Before we go on to Robert, I just want to interject and say I've had some correspondence with Ashwin De Wolf, who is and he has a very interesting paper that came out in Rejuvenation Research, where they looked at I believe it was rat brains in that were either in an ice bath at 32 degrees or normal thermal temperatures. And what struck me about and then they let after these rats died, they had the brains just sitting there for a certain amount of time, and then they sliced them and imaged them. What struck me was how quickly the brain starts to decay after metabolism ceases. So just like an hour or two later, you can visibly see the vesicles are disintegrating. It's actually quite shocking.
Yeah,
And
you know,
anyone who wants
people
to see that visually can look at this paper. They have images of it.
people think the brain just disintegrates. Some people think the brain disintegrates like almost instantly as soon as oxygen
It really have
stops
to
being
cool it
transported.
very quickly. I mean, otherwise, it starts disintegrating. Yeah.
Yeah, so the truth is like kind of between the folk wisdom, right? It's like the brain's not disintegrated even 10 minutes or 20 minutes after end of life, but by an hour it does really start to look quite bad.
Right.
So
Yeah.
a quick follow-up, and both Ken and Robert may answer this. If there is some resistance, as you observe from the cryonics community, to incorporate glutaraldehyde preservation into the suite of cryopreservation techniques, why do you think that resistance is there? Is it because they don't believe this form of preservation to be reversible? Now, Ken, you seem not to see the point of reversing it, but assuming that somebody has an interest to revive that biological organism, do you think the cryonics community has concluded that this method of fixation is too difficult to reverse compared to conventional vitrification, which is also, as the term suggests, turning a tissue to glass? That seems difficult to reverse as well.
Let me take this, Robert, initially. So one thing is, one of the reasons, perhaps, why the cryonics community did not jump on developing aldehyde-stabilized cryopreservation and offering it is because I personally told them not to. I personally told them that they should not, and no other person should develop aldehyde-stabilized cryopreservation and start offering it to people, because there is a proper way of doing things like this. If we were looking at any other medical procedure, let's say somebody developed a potential cure for cancer, if you were to then start giving that to cancer patients, you have completely undermined your credibility with the rest of the medical community. And so, we finally have a technique, aldehyde stabilized cryopreservation, that can meet and exceed the stringent criteria that, for example, the neuroscience community would expect. Let's develop that in the closest way that we can to any other medical technique, and put it to the scientists and the medical ethicists, et cetera, to try to get this developed into a procedure that can be applied in hospitals. Because if you look at what has happened with cryonics is for 50 years, it's a little tiny niche industry that people think is crappy, and the scientific community won't touch it with a 10-foot pole. That could happen with ASC. That could happen with ASC for all the wrong reasons, because ASC, like I said, it can meet the criteria that any neuroscientist would put. But it can happen if somebody, some jackass, goes out and starts selling it to people. Okay, and so there is a certain very careful methodology that we need to go through to get the neuroscience and medical ethics communities on board. And that's what, at the Brain Preservation Foundation, that's what we're committed to. Because we want a world, we don't want a world where 20 years from now there's a whole bunch of rich guys that are in, like a dozen rich guys in a bunker that have their brains well preserved. We want a world where every single human being in every country of the world, no matter how poor they are, those people's rights are to have their brain preserved in a method that is absolutely scientifically verified to preserve the information content of the brain. That's what we're looking for. And I am thankful that the cryonics community has, for whatever reason, decided not to implement this, because I think if they did, they would screw it up.
Well, it's interesting because you mentioned that current cryopreservation techniques are not able to preserve the structures of the brain nearly to the same extent as glutaraldehyde preservation. But I think it's important to consider how much fidelity is needed to achieve a successful reconstruction of the individual. And this is an area that I think has many interesting implications. In our chat, Rudy Hoffman, who of course is a prominent figure in the cryonics community, also a friend of mine, says, we also know that large amounts of brain damage do not completely eliminate our sense of self, although such damage is clearly not ideal. So if someone suffers a traumatic brain injury, for example, they might lose some of their memories, they might lose some of their cognitive abilities, but gradually they could regain some subset of what they've lost. And I'm curious, if you have an imperfectly preserved brain, but you have technologies like the ones that might be able to read the memories of a glutaraldehyde preserved brain, is there some sense in which they could fill in the gaps? Like if you have a puzzle with most of the pieces, can you supply the missing pieces through inference?
I hear exactly what you're saying.
Yeah. So maybe, but think of there's an analogy where you think of brains as like being these watches or something, right? Like a geared system. So you mess up one gear, you damage the structure a little bit. It's sort of obvious how to fix that, right? And it might be more reasonable to think of brains as like an incredibly intricate soap bubble network, right? Where if you crush that or damage it in a certain way, certain things merge together, and it's very difficult to then figure out what's going on, right? The other thing I would say is we may have even evolved to some degree to be able to deal with some of the more common ways in which a brain might be damaged, right? But that doesn't, the same way that a CD, right, has been designed that a single scratch isn't going to damage it because they get scratched a lot, right? But for something like cryopreservation that never naturally occurs, it's less clear that you can infer from that a brain can take some type of damage to this type of damage that's applied everywhere throughout the brain is going to be okay. What I would say is, if you look at modern neuroscience, right, we say that changes in synaptic weights encode long-term memories. So if you're making it ambiguous what the synaptic weights were, then that's probably going to be bad. So you can certainly say, is a preservation technique better than another preservation technique relative to modern neuroscience by looking at what it does to synapses.
Yeah, but the fact of the matter is that we, at least I have no idea how good or how bad cryonics preserves brains. I mean, I have a little bit of an idea. I think it's bad, but who knows? Maybe I'm wrong. If you are confident enough to actually sell this technique to people, you should be confident enough to publish real evidence for how well this works to preserve the structures of the brain. And the cryonics community, I'm sorry, I want to piss off somebody, okay? The cryonics community has hidden behind a legal wall for decades, okay? It is the legal wall that says we will only touch, we will only, quote, preserve people after they're dead. And so we can't screw that up. So don't bother us, and you don't have to think about us, right? And for 50 years, I think they've been producing, horribly preserved brains under that circumstance. If, on the other hand, you went to the medical community and the neuroscience community and said, look, we demand this be taken seriously. This is a life and death issue. We do not want to be forced to only get preserved after it is too late for us. We want this as a form of euthanasia, okay? We want to have access to this because this might be the only thing. There are tons of terminal patients who know that they are going to die. Modern medicine cannot help them at all. They know when they're going to die. They know how much suffering they're going to go through before that. They know how much brain damage they're going to undergo, and to essentially force them to die by, quote, natural causes, and then wait 30 minutes until somebody signs a piece of paper, and then get shoved over into a cryonics business that is not regulated at all, has no scientific grounding from a peer-reviewed published point of view at all. We need to get beyond that. And that's what the Brain Preservation Foundation is trying to do. We're saying, forget about it. Don't even, cryonics is the only thing that cryonics has done is it has made it more difficult for your run-of-the-mill scientist and medical individual to take this seriously. So let's throw out all of that baggage, all of those preconceptions about, oh, well, we're going to have to start after people are dead, even if it would be way, way, way better of a preservation if you started before they were dead. Throw all of that out and just have a legitimate conversation with the scientific and medical community about this. And I think if we can get that going, then 5 or 10 years from now, we could literally have every single hospital in the United States or in the world giving this as an option to terminal patients.
Wow.
If I may, I do think you've identified what may be the key point of disagreement between us, Ken, and that is when we think these procedures should begin. And there's a lot of philosophical underpinning that I could go into for thinking the way I do, and I hope to later on in the salon. But the key difference is whether the preservation should begin after legal death is declared by other causes, or whether in some manner legal death should be hastened in order to arrive at what could be considered a higher quality of preservation. This is, by the way, where the question of future technology being able to fill in the gaps is also a crucial one to consider, because if you have Alzheimer's disease, for example, and your brain, when you die, according to today's legal definition, is not going to have as much content as you would want to preserve, ideally, in a healthy brain. Would that perhaps be all right if the future technologies are able to restore you to the pre-Alzheimer's state? But even more importantly, it seems to me the cryonics community has pursued this option of waiting for legal death before preserving an individual, specifically in order to be able to make any sorts of preservations at all. Because even from a pragmatic standpoint, euthanasia is highly controversial. I personally reject it from a moral standpoint, but from just looking out at what will society accept, what will people be allowed to do? If you're performing a procedure on what is already a corpse by today's definition, then what are the alternatives? You could bury it, you could cremate it, you could mummify it potentially. So whatever the cryonicists do with it is a higher quality of preservation than the traditional techniques. And likewise, I could conceive of some corpses by today's definition being stabilized using glutaraldehyde preservation. That's also a higher fidelity preservation than any of the traditionally available means. And I think that would be a lot more palatable to the general public. And yes, you could have scientific rigor built up around it, but it would be much easier to have a sample of any size of actual patients who have undergone this procedure if they're legally dead, and you don't have the whole regulatory apparatus impinging on one's ability to undertake the preservations in the first place.
So there's two things I'd like to comment on that really fast. One is, I think that this is a little bit backwards. You can say, here's what we would desire, right? Like, what would I desire the most for a heart transplant, right? Well, ideally, I would simply be able to believe that my heart is transplanted. If a doctor says you need a heart transplant, right? It's simply wishing for it, and it would suddenly be done. That would be my ideal heart transplant surgery without any constraints of reality, right? But that's not how you design each type of surgery, right? You design it based on constraints of reality, and some things may or may not be possible. So I think instead of saying, let's start with palatability, or let's start with what would be convenient under a legal framework, you should start with what does neuroscience say is necessary to preserve the information content of a brain? And then from that say, okay, how do we design a validated protocol that can meet these requirements, and what are the trade-offs, right? So I turn it around like that. And then the second thing is this whole business of dying is way more complex than people normally give it credit for, right? The movie, someone just sort of is sitting there and their loved ones are around them, and they, say something profound, and then they just sort of close their eyes and die. And that does sometimes happen, but it's extraordinarily rare. I've never seen it happen. In reality, there's a pre-mortem interval that can last days, where the person's comatose. You even potentially have necrotic tissue in the brain, but it's still barely able to keep the person's heart beating, so that by the time their heart does stop and they're declared legally dead, their brain is literally necrotic. So in those types of situations, there's no possible way you could wait, even if you could magically at the moment of legal death preserve that person, their brain's still profoundly damaged, right? So the course over which person dies, there's a lot of complex things that happen there. One thing I do know for sure is that you can't wait hours after a person has died to then preserve them. It would be great if that could work. The greatest preservation would be someone dies, and a week later, the family is like, oh, hey, what if we could retroactively preserve them, and they could just fill out a form and they'd be preserved, right? But unfortunately, that just isn't how it could work. I've seen brainstorm a brain bank, right, where a person passed away, they donate their brain to science, and that brain is then extracted, say 6 or 10 hours after death, and then immersed in formaldehyde, right? So the outer layer of the brain is fixed, and then progressively deteriorates as the fixative's going in. Even taking a sample from the outermost region of that brain, that would be the most good-looking part of that brain, it is just catastrophically ruined. If you look at synapses, you can barely find a synapse, or you'll find half of a synapse or something. So I do know that there's some things that definitely don't work.
Yeah, if I might interject, this is actually a good time to address a question from David Wood in the chat, because he's asking if you guys have any opinion on MRI scans of cryopreserved patients. And he says, he says he saw a something from one of the cryonics companies, which was a brain scan, possibly CT or MRI.
Yes, he says.
And Hayworth, Dr. Hayworth mentioned that these cryonics companies, they really haven't been very transparent, and you really wonder why that is. So, but apparently they've released some scans. So I was wondering if you had any opinion on that.
David Wood says it was a CT scan.
Yeah.
Well, a CT
Right.
cannot show anything of the brain really, and an MRI doesn't really give any detail. But
yeah. So the question is, what are these measuring?
Experts
right?
here speak.
Go ahead, Robert.
Oh, well, so the question is, what are these CT scans measuring, right? And they're trying to find cryoprotectant concentration. So the typical cryonics protocol is establish good perfusion, ramp cryoprotective agents to an appropriate concentration, and then vitrify, right? And part of the problem of dealing with someone after they passed away is it can be very difficult to perfuse that person, right? And so if there's major blockages in arterioles in the brain, then you're going to get an incomplete perfusion. You're going to try to have an even distribution of cryoprotectant throughout the brain, but you're going to fail at that. There'll be some regions of the brain that have no cryoprotectant that still have blood in them. So one of the effects of putting in a lot of cryoprotectant into the brain is it causes a lot of osmotic shrinkage. It will literally suck the water out of the cells faster than the cryoprotectant goes into the cells, and it sort of osmotically crushes everything it comes into contact with. And that crushing effect is considered desirable, right? That's the effect that they're trying to measure with these scans. They're seeing how much did it shrink, how much cryoprotectant got in there.
Just to be clear,
yeah.
It's desirable because it is a marker of getting enough cryoprotectant concentration.
Yeah,
that
I'm not saying it is desirable. It's just that's the what they're playing here, right? And so, like, saying, first of all, if a CT scan says that the brain wasn't perfused, then that's an absolute disaster, right? You know that brain's going to look like absolute garbage. Not only is it going to be heavily disintegrated because of the large amount of postmortem time, but then it also will be frozen, which will just utterly destroy it. If the CT scan shows that the brain was well perfused and has a lot of cryoprotectant in it, then it simply showed that the protocol was done as it was designed, but it doesn't show that the protocol itself preserves information.
Right. I imagine you would need a microscopic, you need those electron microscope images for that, right?
Right. And any electron microscope image, you can't make anything out of it because it's too shrunken.
Well, that's right. And let me say what the cryonics community, because I don't want to give a false impression of what the cryonics community says about these things. The cryonics community in general would say, yes, the current protocols are shrinking brain tissue because that's the best way of getting a high enough concentration that prevents ice crystal formation, and that's really what we're trying to get to. And then when you look at those under the electron micrograph, under the electron microscope, it is difficult to determine if there was any damage. Okay, so for example, I've looked at these electron micrographs, and it is really difficult to determine if there's damage in these. Okay, because they look all distorted and everything. And so, when I was running the Brain Preservation Prize, I of course didn't say, "Oh, well, there you go, it doesn't work." I simply said, "That's fine. If there is some other level of information that you can provide." For example, if there is a way to take that preserved tissue and then rehydrate it so that you are able to expand it back out and then prepare it for electron microscopy and show that under those circumstances you get preservation of connectivity and synaptic structure, then you win the prize. I mean, when my organization first put out this prize, I would have initially I thought the cryonics community would come in like that. I mean, they've been doing this for 50 years, for God's sake. I figured, the hardest part would be for me to get the skeptics on board to listen to the cryonics community present their evidence. And the skeptics, for the most part, got on board, and the cryonics community dropped the damn ball. So, I'm sorry for those members of the cryonics community that's out there that's listening to this. Pick up the ball and publish in peer review journals how good the current cryonics procedures are. And it's not me that you have to convince; it's the scientific community that you have to convince. It's somewhat of a moot point to, because think about it. We've been for literally decades, we've been kind of been trained to accept the idea that cryonics is bad, but we don't know how bad it is because for some reason we don't know. We can't even quantify how bad it is, but it's the only game in town, and you would rather be in the cryonics group than the control group. Well, guess what? There's a different game in town, okay? It's called what neuroscientists have been doing for decades, and it does a way, way, way better job is such a good job that we can actually publish in peer-reviewed journals about how good of brain preservation it does. And so it is time for the cryonics community to essentially, I don't know, shut the doors until they are able to meet the level of criteria that the medical and scientific community can do. And it's also, like I was saying, it is not appropriate for even this aldehyde stabilized cryopreservation to go out there and start preserving people. We're at a different level here, where we've got a technique that works in the laboratory to preserve whole mammalian brains. The next step is to develop it into a medical procedure that can be offered under conditions that we know will work. And if those conditions require euthanasia, then those conditions require euthanasia. If they don't require euthanasia, then somebody has to show with new experiments that they can be performed after death under these circumstances. That's the real criteria.
Well, the question that arises for me is, what do we do with people who die in the meantime? Unfortunately, the people who become legally dead today are not going to wait however many years it will take to fully scientifically vet a particular procedure. At least the cryonicists are offering something today, which to those people would be better than nothing. Now, admittedly, for someone like myself, I wouldn't want to undergo cryopreservation tomorrow. I wouldn't want to undergo cryopreservation in 50 years or 100 years if I can avoid it. The cryonics community calls it Plan B. So to those people who cannot have recourse to Plan A, which is biological life extension and rejuvenation, wouldn't it be good to have some sort of Plan B, however imperfect?
I think the answer to that is the same answer you would give to if you were developing a cancer treatment. And it was so speculative that that the governmental regulations were very clear that, okay, now you need to do these studies in mice because this is a very speculative procedure. To try to do an end run around that, it backfires. And so what I'm saying is that let me be as controversial as possible. If cryonics had held its powder, okay, if cryonicists had in the 1960s and 1970s and 1980s, if they had looked at the results that they got and tried to show it to the scientific community, and the scientific community said, "Whoa, that ain't preserving, anywhere near what we think should be preserving." If they had essentially kept doing the experiments, and the people that were dying at that time, they sucked it up and died. And I'm saying that from my perspective. I am probably going to have to suck it up and die because we're going so slowly on this road. But I would rather suck it up and die than to do an end run, get myself preserved, and then make sure that another decade or 2 or 3 or 4 is wasted because the scientific community will not embrace it anymore. And that's exactly so. I'm saying that type of logic has killed people. That type of logic has killed people. If the cryonicists had not developed had not started applying it in a humane, they did it for the best causes, that's fine. But if they had not jumped the gun on that, then we would be in a much better situation with the general scientific and medical community about developing and deploying something like this. And
please correct me if I'm wrong, Hayworth, but I think that it might be the case. Some people are thinking, oh, Hayworth's saying this needs to have like a full clinical trial, and it needs to be something that's like, the 10-year development process that a drug gets, right? But I think what you're saying is that as a society, we already literally have standards for risky experimental things you take if they're at the end of life and you don't have any other good options. And so the same laws and the same ideas and spirit that apply for an experimental cancer treatment where there's little evidence that it works, it's not something that's a huge medicine yet. That we still make a case where if you have proper informed consent, you can then take advantage of that. But we don't say that just anything, right? That you can take advantage of that, and then that's codified in laws we have. Is that correct?
That's right. Although, so let me be clear. I piss off the cryonics community, but I piss off the neuroscience community as much or more. So there are, when I am talking to a neuroscience crowd, and they say, yes, the proper thing to do would be to wait to apply this until we know that it will allow people to be revived. Well, that's going to take 100 years. Okay, and so that's stupid that they bring that up, and I point that out absolutely, that is not a legitimate criteria. Okay, if they say, we need these really, really difficult memory experiments where, I had somebody the other day on Twitter say, if, because I was asking, well, what does the neuroscience community need to see before they embrace this technology? And one neuroscientist said, well, if they map an entire mouse connectome and then show that they can retrieve high-level memories and behaviors in a non-trivial manner from it, then that would open minds. And I was like, dude, that is, that is going to condemn generations to death if we are on that type of slow road. There is a logical set of milestones, set of criteria that people should meet to get there. It is extremely logical, and I am pushing for that. And I realize that the cryonics community wants to say, we're already there, it's fine, don't worry about it, just let us keep doing what we're doing. And the scientific community a lot of times says, we don't want to even hear about this because this is like crazy stuff and we don't want to be associated with it. And what the BPF is designed to do is it's designed to grab both of them by the scruff of the neck and make them play well together.
So let's go back. Yeah. Let's go back to our DNA analogy, right? Like, let's say that it's not the late 50s, but it's the 30s. Okay. And we're saying, well, we don't know enough about how the hereditary information of individuals is stored. So, but we still want to do something, right? And we think it's maybe proteins or whatever. So we'll just try to grab the proteins out of an animal and preserve those in some haphazard way, right? And hope that it's better and say, well, it's good enough, right? And you have a tradition of doing that, and now it's getting towards the late 50s, right? And we understand more about how DNA works. Okay, do you say, well, let's just keep going with the protein-based method, or do you say, there's some standards that we understand now, and we can actually be fairly confident we can preserve this. Let's develop that into a rigorous method to archive species DNA, or we're not going to be able to preserve anything. And it's still highly experimental, and it's still highly speculative, right? Because you don't know if you're going to be able to ever read this DNA. But it seems like there's a reasonable middle ground here that really we've already kind of worked out as a society anyway when it comes to right to try laws for experimental drugs at the end of life. We acknowledge there's absolutely is a lower bar because this logic of, well, what's your alternative? You die? Well, yeah, that's pretty reasonable logic. So, absolutely there should be more of a choice as you approach the end of your life, and society agrees with that. And I think those are fairly reasonable, right? So what does that mean for applying to cryonics? I think that what Hayworth is saying is very reasonable, that you need to be consistent with modern neuroscience, especially since we can be consistent with modern neuroscience. And you have to have an even greater focus on informed consent, specifically because of the speculative nature of it.
But at the same time, I don't think anyone should suck it up and die, because ultimately, from my ethical standpoint, the death of the individual is the greatest evil that can occur. So from my standpoint, if I die, that's it. I lose. The universe is destroyed for me, essentially. And that's the same from the standpoint of every other individual. So if they have no other good options, if medical science, based on what is known or demonstrated clinically, says, sorry, we can't help you, then at that point, why is it wrong to allow that individual the right to try any technique, however remote, however speculative? And this is where the right to try discussion comes in. So David Shoemaker asked in the chat, is there a role for right to try with brain preservation techniques for individuals who accept the risk? And then we also have a comment from Karamiko Studios in the YouTube chat who says current cryotech should be a deathbed right to try option. And in some cases it is already, because of this legal death loophole, which greatly lowers the bar for what procedures may be undertaken on a person who is legally dead. So what do you think of some sort of right to try option if the calculus is, if you're dead and you're not preserved in some way, then you're gone with 100% certainty. But if you are preserved in some manner, however speculative, maybe it's cryonics, maybe it's glutaraldehyde stabilization, maybe it's something else, then at least there's a non-zero probability, however small, that you can be revived in some form.
Well, I mean, I hear exactly the argument that you're making. I agree with it at a certain level. At the human level, I agree with it, no question. I am talking about a strategic goal, I think, that if we want high quality preservation to be a right of all human, we need to engage with the scientific and medical communities on their grounds. And that is not that's not the same thing as saying we should just allow every single possible technique to happen. There are certain medical techniques that we do not allow people to undertake because they have not made they haven't been through enough rigorous testing.
But
sense?
Perhaps some of these restrictions are the result of improper incentives within the regulatory agencies. That is, if a regulatory agency approves a speculative treatment and something goes wrong, the officials get blamed. If death just takes its course, but the officials involved had no part in any decision, then, oh well, terrible things happen in the world all the time. And I think this is the kind of skewed incentive structure that leads the precautionary principle to be favored over the proactionary principle so often. But could there be ways to overcome that through different structures, through different ways of operating within the scientific community? Perhaps not telling scientists, okay, we want you to accept everything that contemporary cryonics does, but let's put that aside for a moment and let them do what they do, but also undertake some more rigorous set of studies designed to give the requisite comfort level to the scientists who are skeptical.
Sure, but those incentives can cut both ways. You're sort of eloquently expressing the concerns that a regulatory agency has, but these incentives work for the preservation company as well. If you preserve someone, right, with a technique that, you know, regardless of what the technique is, right, once you've actually done that and you've done those preservations, and then let's say you have a tradition of doing them, so you've been doing them for 10 years, then are you incentivized to research to develop a better technique? Because then that technique, if you do develop it, is implicitly saying that your previous techniques didn't really work very well, right? So you can very easily get trapped and stuck with a long tradition of preserving people that incentivizes you to do your research more on saying this is why our current thing's probably fine, rather than saying let's trash our current thing. But the more productive research normally always comes from let's just trash whatever we have right now and make it better. So the line, why not have the line be, here's what neuroscience says?
I'm curious how much, I mean, what is really holding back research in this area? And I'm actually a little bit skeptical if it is this stigma from cryonics. Because, you know, what I see a little bit is I understand like maybe scientists don't want to be saying like, oh yes, I'm researching cryopreservations like cryonics, because they look like kooks, right? Because it's cryonics right now is completely unregulated. They're making pie in the sky claims. They're putting extreme faith in future technology to basically infer missing information, right? That may be, you know, missing there. So I completely understand why scientists wouldn't want to be associated with that, but couldn't scientists possibly, you know, rebrand themselves as connectomics researchers, for instance, because connectomics is very popular, or maybe biostasis or something like that?
Well, you go on. Go ahead.
I was going to say that, you know, there's going to be a stigma no matter what. I mean, I am saying something that is probably it's definitely less socially acceptable in our good Christian country. You know, I'm saying that that I believe neuroscience. I believe that that we are computational. I believe that neuroscience already knows a whole bunch about how the brain works at a computational level enough to preserve long-term memories, and I believe that that neuroscience will be successful in a few centuries and be able to upload people into you know, brain simulations controlling robotic bodies. Absolutely, people want to distance themselves from that. And you know, they want to distance themselves from that because they would probably be distancing themselves, you know, if it was the 1920s and somebody said that you know, these newfangled rocket things, they could actually land somebody on the moon, they would want to distance themselves from that nonsense as well. So I
mean, I understand there's a lot of like inferential steps, a lot of things you have to know in order, like, for the general public to be at the level you guys are at. But what about other researchers in neuroscience? Like, what's stopping them from getting into this and researching it?
Well, I ask myself that every day. I have to say that at least the researchers that I surround myself with are not. A lot of them just simply agree with me, and I haven't seen a single one that really gives a good argument that ASC, this aldehyde stabilized cryopreservation technique, is not meeting the criteria of what textbook models think is encoding memories. The best that they can do is to say it may not work, which is kind of not relevant. It's like, yes, it may not work, of course, but what we should really be saying is, given all of the information that we have today, is it reasonably likely that it will work? And they all have to essentially say yes, because it just happens to be the case. I mean, the facts are the facts, and I'll debate any neuroscientist on this that wants to in any venue. But at the same time, with few exceptions, they will not go out in public and say and embrace this possibility.
Now this, yeah, sorry, go ahead.
Well, and I'm just, you know, it is a failure of myself, and it's a failure of the Brain Preservation Foundation that we have not yet. We're trying, but we have not yet brought about a revolution in the neuroscience community where they embrace that. And I, you know, I'm making the argument in the places that I can, social media, etc., YouTube,
to basically tell the neuroscience community, look, you should embrace the possibility that you may succeed. You should embrace the ramifications that has for mankind, and not
not essentially you think people doing connectomics should be going on board with this and using it to promote connectomics.
Absolutely. I mean, it's absolutely ludicrous. It's absolutely ludicrous that the National Institutes of Health is contemplating spending $100 million or more on mapping the connectome of a mouse brain, and yet they cannot make the simple connection of what that research may imply for human health. This is human health. The NIH, you guys are, 100% of us are dying. 100%. You are failing 100%. And there is one technology that could meaningfully impact us, and that's preservation technology in general. And you're putting 0 cents into it, and yet you're saying that we should get excited about mouse brain connectome because what does the brain do again? Because apparently you bought into the mysticism of the mind is not the brain. So don't try to sell us that you should fund more neuroscience. If that's the way you're going to play it, then we don't need to fund any more of this damn neuroscience, because you guys have already said you're going to fail. Okay, so like I said, I'm dishing it out to the chronics community, but I'm dishing it out to the neuroscience community just as hard.
So what would you say would be the probability of successful eventual reanimation in some form of an individual whose brain was preserved through aldehyde stabilization? Would you be able to assign some sort of rough probability to that? Do you think it's 5%, 25%, 50, 75, 90%?
I mean, I think we can make very concrete statements about the aldehyde stabilized cryopreservation is preserving everything that modern neuroscience models suggest encode long-term memory. It is preserving way more information that casts a much larger net into the realm of possible mechanisms that the brain might use to encode information, because it is literally preserving essentially every protein and the location and identity of every protein in the brain, along with the connectome, the synapses, and structural information, all this other stuff. I mean, there is some change, obviously, when you glutaraldehyde perfuse a brain and then store it at low temperatures, but it is when you compare it to modern neuroscience understanding, it is fantastically good at preserving the information content of a brain. So if you ask your question in the manner of what percentage likelihood do we give for that ASC is preserving sufficient, it's sufficient to allow that to happen in the future, I would say it is approaching 100%. Approaching 100%. Okay. Now, does that mean that somebody that is preserved today will actually be revived? That's a question of future politics, future social structures, long-term preservation, storage, all of those things. But if you were to remove those things, we get into the realm of much greater than 90% chance if the procedure is done correctly. That's my opinion on it.
Thank you. And Robert, do you agree with that assessment, or do you have anything to add?
I'd say that either neuroscience is like catastrophically wrong about how memory is stored, like to the point of being fraudulent, like some of the core things actually being literally frauds, or ASC preserves long-term memory. So one or the other.
I had a question going back to this discussion of research. I would love to see more research in both this fixation and a traditional cryoprotection. But I was wondering what the relation is to this other field of cryobiology, or cryo. There's cryonics, and then there's cryology.
Cryogenics.
So cryogenics, yeah. So are there people in the cryogenics community who are moving in the direction of researching a brain preservation or cryopreservation of the brain?
All right, let me just break this down real fast. Cryogenics is study of cold. So those are like the guys who figure out how to do Bose-Einstein condensates. They figure out how to make liquid helium and hydrogen, liquid nitrogen. You know, were done by the cryogenics people of the last century. Cryobiology is specifically the study of cold with biological systems, including chilling injury, freezing, and then cryoprotection is like a subset of that. And then cryonics is saying, like, let's apply some of the technologies of cryobiology on humans in a post-mortem context. So the cryogenics guys, probably not. The cryobiology guys, it's a very small scientific group. It's not amazingly well funded. There's only a couple hundred scientists that really work on cryobiology research. And they're mostly concerned, like if you read the journals of cryobiological research, like a large amount of it is preserving sperm and preserving eggs from various different species, because that's the most economically productive research. Because if you can figure out how to, say, preserve duck sperm twice as good as competitive methods, then farms everywhere across the world are going to use that technology. If it's, you know, not too much more expensive. So that's kind of the state of it right now. There's been some push, but yeah.
This feeds into a really interesting question from Liz Parrish. I don't know if she wants to ask it, but herself, but she wrote here, and she's wondering, have any groups looked at genetic options for tissue storage? And so she's saying the example would be the tardigrade, which has a set of genes that help it survive drying out. So basically, she's asking if people have looked at you know, some of these organisms like insects, tardigrades, and the specific genes they have, and if we might be able to have like a gene therapy that would implement that in humans.
There's two things on that. It's, first of all, it's monstrously complicated to even take someone that doesn't have those genes and express that gene in every neuron in their brain. As far as I understand it, it can't be done today. So even if we had a way to like grow an organism that would have these genes, then you wouldn't be able to apply that on someone who actually needs a technology today. And then second of all,
but could it possibly be not a gene therapy, but essentially in a what's the word, genetic engineering of children, basically. I forget the technical term.
So let's say, so a lot of these animals, they basically make a bunch of sugars like trehalose, and then they rely on a combination of dehydration and cryoprotection to survive. And so there's a question of whether that works well for a brain in particular. So first of all, you could keep every single cell in a human brain alive, but erase the data that's stored in the brain, right? Like if you think of an individual neuron, right? It's connected up to all these other neurons. It doesn't understand what it's doing, right? It just gets input, it makes a fairly simple computation, it shoots out output. I mean, even a cell is still a monstrously complex little organism on itself, but you know, it sort of doesn't care exactly what it's hooked up to, right? Whether it's part of calculating some muscle reaction or part of calculating like a receptive field for a face, it's the same circuitry, the same biology, right? So if you just scrambled all of the synaptic connections in a brain, every cell could still be alive and perfectly happy and functional. and that mind would be destroyed, right? So cryobiology's like fundamental assumption, right, about life is that you have a cell that's a bag of stuff, right? And you want to preserve the cell so it's still alive, right? If you want to preserve a person, you need to not only preserve the life of the cells of that person, but you also need to preserve the actual computations that typically generate that person's mind. And you can do one without the other, or and vice versa. So if you somehow made the individual neurons in a brain be able to deal with dehydration and cryoprotection and survive that, you still might not actually be preserving the information because you may be disrupting that extracellular connection.
Would an example be like, oh, I see what you're saying. I mean, obviously it would have to be verified, but this seems to be like a possibly viable approach, I would think. Basically have the cells manufacture have some kind of genetic switch that you turn on. Not sure how you would do that, but you turn on this switch and then if the cells start manufacturing the cryoprotectant themselves.
So it's one of these things, like, because cryobiology assumes your bags of stuff, right, and you're trying to keep them alive, where cryobiology has had the most difficulty is in tissues that do a lot of stuff in the extracellular matrix or have a lot of extracellular structure to them, right? So like we learned how to preserve sperm in single cells in the 50s and it worked great. And everyone thought, well, how hard could it be to preserve a whole organ, right? And then we're still trying to preserve organs today. And it's because, I mean, it's hard, but I think it's not helped by the fundamental assumption of cryobiology kind of ignoring the extracellular space. And so you end up damaging that. And that's why organs tend to not cryopreserve super well. And the brain's the worst of all of them, right? Because the brain's, it's almost like the core of a neuron is sort of just there for fun, right? It builds material, but it sends it out. And most of the cytoplasm's in the dendritic arbor, right? And, you know, all of the data is kind of stored outside of the main body of the neuron. So you disrupt the extracellular space, you're gonna have a lot of problems.
I would also point out that unless I'm wrong, there is no animal model that could actually be preserved for hundreds of years, and that's really the type of time frame that we have to be thinking about.
Yeah, so like if you took that tardigrade, the tardigrade really could vitrify, and if it vitrifies, it could go for 100 years if you protected it from like cosmic rays and stuff. But if you take these frogs that are less extreme version, right, where they dehydrate a little bit, right, there's still actually a little bit of aqueous stuff. It's a super saturated, salty, concentrated remnant liquid that's in those cells. And if you force that to freeze, you'll kill the animal. Like the frogs that can freeze, the Sylvatica frogs, I mean, they really are frozen, right? They at least they look frozen. But if you then took that frog and like put it in liquid nitrogen and cooled it down to a temperature that really freezes it, then the frog dies.
It would crystallize, essentially, you're saying.
Yeah, it'll finish off that last little bit of stuff.
At a very low temperature, which
right,
is what
but the problem is
for very, very long
right
shutdown of the.
If you took a Sylvatica frog and you froze it for 20 years, it would not be able to recover from that. Now, on the other hand, if you had a technique like that, you could extend someone's life. You know, like the original idea I had like 10 years ago or whatever that I thought was cool would be this idea of you just pause someone, right? So you'd literally, let's say you're 50, right? Oh, okay, I have 30 years left if I'm going to live to 80, right? But I want it to be 60 years. So you go into this preservation thing for a month and then you come out for a month, right? And that way you can live in society, you can manage your affairs. You've just sort of doubled that 30 years to 60 years, right? And you live 20 years that way. And then you're like, well, you know, let's say I only have 10 years left, right? And you feel like the life extension technology is not going to get there. Well, multiply it to 40. You know, you go in 1 week and
right. And
you go
I
in
want
for 3 weeks, you're out for 1 week.
You know, I'm sure a lot of our viewers know this, but I just want to throw in that this is also very important for space colonization, because we're not going to be able to travel faster than light. It's going to be very hard to travel any significant fraction of the speed of light. So in order for humanity to travel to other stars, I mean, we're going to need to be able to be in spaceships for thousands of years. And so there's this dream of having sleeper ships, right? And so this is of great consequence, actually, this type of technology,
Right.
not just for all the things you guys are talking about, like preserving memories and everything, but also space exploration.
But here's
Of
the other
course.
problem, right? Let's say we do get, even if we had reversible human suspended animation, right? Like, I imagine the first version of it maybe will work on like an extremely fit Marine, right? You know, the type of person that would be able to stand the rigors of space travel, and it would only kill them maybe 20% of the time. But it's still, you know, that alone would still be a miraculous technology. But just because it works like that on a very physically fit individual doesn't mean that it's going to work on a geriatric 86-year-old person with a lot of comorbidities, right? It's probably always going to kill that person because it's very stressful even for the organisms that can survive it to get dehydrated like that.
Of course, this kind of suspended animation technology would be quite different from any of the preservation techniques that have been advocated thus far, because there wouldn't be any component of the preservation process that destroys any tissues or fixes them in a way that's difficult to reverse. Essentially, the stereotypical view is you'd step into some sort of stasis chamber and it's like you've fallen asleep, but somehow all your systems are stabilized and then you can just wake up when needed.
Again, it's hard to predict future technology, but I wouldn't be surprised if we figure out how to do uploading before we figure out how to do reversible suspended human animation. And we may just never bother with it because you can just
that's a good
transmit information from one point to another at that point.
Now, this is where preservation of identity and continuity of consciousness comes in, but we'll discuss that a little later. Ken, what did you want to say?
Well, I just wanted to say that I think from a the most relevant thing to base decisions off of is when do you think these not that you should you be putting research dollars into cryobiology? Of course you should. Should you be putting research dollars into regular cryonics? Yes, I think people should. Should we be looking for anti-aging? Absolutely. But if we're making decisions and we're trying to say when is one of these going to come in, all of these except aldehyde-based cryopreservation are potentially many decades away in my from what I've seen. And so if we're thinking about what to do today in order to preserve people, you shouldn't be waiting for one of these long shot technologies to come in and save the day.
So I want to pose one more question before we get into the continuity of consciousness discussion, though I will say we have many questions and hopefully we'll get to address most of them in the course of this conversation. Rudy Hoffman says he has a friendly, i.e. non-confrontational tech question, which is how does glutaraldehyde obtain full perfusion in large brains like those of pigs and humans? And I think he's pointing to the difficulty in preserving large mammals more generally compared to simpler organisms like C. elegans, for example. So how would the glutaraldehyde succeed in obtaining full perfusion?
If you're alive, then almost by definition, you've got an intact circulatory system that's able to deliver chemicals to every single cell within seconds. And so as long as you can interface with that circulatory system, you can also deliver pretty much anything you want to every cell within seconds. Especially under laboratory conditions, we've already done pigs, we've done rabbits, works fine. And has for many decades since we've been studying these things. So yeah, as long as it's done quickly, you can get it everywhere.
And a related question from Liz Parrish, I will ask it now because it's convenient. Has the aldehyde stabilization technique worked in organs to prolong their health in a way that those organs could be successfully transplanted? That is, has it ever been done on an organ other than the brain of an animal that could then get that organ back?
Yeah, so people need to understand that the first step of aldehyde stabilized cryopreservation is to perfuse with one of the most deadly chemicals possible. It shuts down all metabolism at the molecular scale. That is the point of perfusion with glutaraldehydes. So within a minute, you're as dead as a rock, and you ain't coming back by anything short of extreme future technology.
To give you an idea, like medical grade sterilants are like 0.1% glutaraldehyde. And that's considered fine to just eliminate any sort of biological contaminant. And this stuff's 3% glutaraldehyde. So nothing can survive that.
Right. And perhaps this is one of the reasons why the cryonics community may have been reluctant to use that preservation technique, because that is very difficult to reverse by your description. But I also think this comment is a good bridge into the discussion on continuity of consciousness, because you said this preservation technique stops all metabolism. It stops all bodily functioning. It is essentially full death, without a doubt, once it's applied. So the only way you have the continuation of some sort of existence is if a different set of techniques is applied to that later on. You propose essentially a kind of destructive mind uploading where you scan the brain in microscopically thin slices, and then you reinstantiate a model of that brain in a computer in the future, perhaps using some technologies that we can't yet conceive of. But this is where the continuity of consciousness idea comes in. And for those of you who are aware of my writing on this, in 2010, I wrote an essay called "How Can I, emphasis I, live forever? What does and does not preserve the self?" in which I essentially posited a view that process continuity of some manner is required to preserve the individual I-ness, as I call it, which is the vantage point of a particular person upon the world. It's not necessarily the pattern of your memories or even the content of your awareness. It's the fact that you perceive the world as you, and I perceive the world as me, and I don't perceive the world as you. And the thought experiment that I performed in that essay was, what if a 100% copy of me were instantiated through some future 3D printing or molecular assembly technology right next to me, and that person had the exact same physical structures of my brain. It's just he was standing or sitting right next to me, and then he could go off and live his own life, and I wouldn't be directly aware of it. Just like when you go off and live your own life, I'm not directly aware of that. So that person might have my memories. That person might think that he's me. That person and I would have some common reference points, and maybe we would get along better than I would with another individual. However, whatever that person's subsequent experiences are would not be my direct experiences. And likewise, if I were destroyed and a few hundred years from now, that same copy were instantiated, I could accept that person could, through some set of future technologies, have my memories and think that he's me, but the version of me that was destroyed would not be directly aware of that person's experiences anymore. So it might be nice as a digital archive. It would be great to have these kinds of instantiations of people who have already died. Wouldn't it be great to converse with an accurate version of Benjamin Franklin or Leonardo da Vinci or Thomas Jefferson? So certainly there is value to that kind of instantiation, but would it preserve the I-ness? And in connection to that, I know, Ken, you said continuity of consciousness is an illusion, but I don't think the kinds of interruptions that occur in sleep or general anesthesia are the ones that we need to be concerned about, because there are still some physical processes operating. Of course, in sleep, you can dream. Even if you go into a very deep sleep, your heart is still beating, your lungs are still taking in air, the rest of your body is functioning, and it's supplying the brain with a variety of resources. So the brain is not dead, you're just not directly aware. In general anesthesia, it's similar. So your heart is still beating at a lower rate, of course, your lungs are still breathing at a lower rate, but enough to keep you alive while your brain is not aware of anything. So the fundamental prerequisites of your consciousness resuming and resuming the same process of consciousness seem to be there. Now, where it becomes a bit ambiguous for me is with suspended animation, the kinds of experiments that have been done on trauma patients, for example, where their blood was evacuated, replaced with a saline solution, and then doctors had more time to operate on their tissues. So when that blood gets put back in, how much of a full cessation of the processes was there? And was there enough functioning of the physical processes to preserve the continuity of consciousness? The same uncertainty exists with cryonics, of course, because the cryopreservation techniques, they're intended to stabilize the body and brain as much as possible, but as you mentioned, they do an imperfect job. So maybe some processes of metabolism continue. Ironically, for me, from my view, the continuation of those metabolic processes is actually what offers hope that the same I-ness might continue upon revival. The problem also comes in with vitrification, of course, where that would be a lot more difficult compared to the very early cryopreservation techniques. But with glutaraldehyde stabilization, as you said, everything stops. So from this process view of continuity, in your view, is there any chance of this I-ness, the I-ness before legal death, in our current era being preserved?
All right, so this is a little complex to get into, but I would like to get into it. But you have to work with me here because there's a lot of pathways to follow, and there was a lot that you said. What I'd like to do is just talk with you, Gennady, and just I'll use you as a surrogate for the rest of the audience. Okay. I think that might make it a little bit easier. And, maybe some other people don't quite agree with exactly what you said, but just in the interest of keeping things simple, let's do that. Are you up for that?
Yes, certainly.
Okay, so let's go through, like I said, there's a few ways to do this. This way is fairly effective, I think. Let's go through a simple thought experiment and tell me what you think about this. So first of all, do you believe that that a computer program could itself be conscious or at the
I think your audio connection was lost when you. Yes.
Yeah.
But if you could restate the question.
Yeah. Do you believe that a sufficiently advanced computer program could itself be a person, be conscious? I mean, even if it's an exact copy of a human brain, that would be included, but
yes,
in software, right?
Yes, I think conceptually it's possible if the physical structures, the substrate in which that program operates can be analogous to the structures of the human brain. Not exactly the same, but have the same emergent property of consciousness be instantiated in them. So hypothetically, could an uploaded human mind in a computer be conscious? I would say yes, but again, it would have the copy problem that I mentioned.
So yeah, so I'm not saying that the uploaded human for now is the same as the first human, but it would be a person in its own right? So yes. Let's say we uploaded me, okay, and so now we're debating about this program. And the reason for this is it can be a little easier to get away from some of the messy realities of biology, which I ultimately think aren't quite as important. So now we're dealing with this person, and this person is still going to have the same sort of issues with their own identity and the same sort of questions about how their identity works as a biological person, all right? You would, I would, great. So imagine that I'm sitting in this room, okay, the simulated version of me, right, which is a person in its own right. And it's an environment, you can interact with it, you can do your things, but the entire thing is simulated, like in the Matrix, right? The whole thing is, you could consider it to be one computer program, and that part of that computer program is the person, and part of it is the environment, right? Now, it's interesting, I think, at least as an aside here, that sometimes you really can know what another person feels or isn't able to feel by the virtue of what we understand about the physical world. A lot of times people say your internal subjective experience is somehow off limits from science entirely, but that's not quite true, all right? A lot of people believe that if they have a loved one that's very far away, let's say 1,000 miles on the other end of the earth, that they would somehow feel that that person has died, right? They would know the moment that it happens. And we know what it feels like to have someone you love die 1,000 miles away with no means to communicate with them. And what it feels like is nothing. It's not possible to gain access to that information in our physical world. And even if you strongly believe that you nevertheless would be able to feel something in that event, we can say with quite confidence that you wouldn't be able to feel anything in that event. So I find that interesting because this is an example of being able to, with confidence, say what another person internally would feel. Would you agree with that?
Well, I would say we can infer what another person would feel because we would have similar feelings in similar situations based on our physiology as well as our life experiences, our cultural context.
No, I mean particularly in the case of someone passing away 1,000 miles away and you have no means to communicate.
Well, if it's the absence of feeling, then I know what that's like. If somebody believes that they have a premonition of some sort, I haven't been in that situation myself. So if there's a kind of positive content of that awareness, then the best I could do is read books about it and try to approximate in my mind how that would feel.
But interestingly, you really can know that there'll be an absence of feeling in that case, or any feelings that they have would be strictly coincidental, right? They're not tied to it the same way. A person that feels like being a member of their church is the absolute highest priority, right? That they want to be part of the body of Christ, might feel like they would know when they're excommunicated from their church without being told, right? But again, in this case, we could say, no, what it feels like to be excommunicated from 1,000 miles away is nothing, right? You have to actually be told that. Or someone that feels a great attachment to their country, right? If suddenly their citizenship was removed or their country fell, right? They wouldn't necessarily know that until they were told that. You feel you're fighting a war, right? And your side has now signed the surrender papers, okay? But you don't find out for another month. You're not going to be able to know that. Okay, so getting back to this simulated person, right? I would say we can know for sure what it feels like in certain circumstances in the simulation. So the first one is we take the current state of the simulation, and the simulation could be as simple as you have a matrix of numbers, right, which is the person and the environment, and you have a state update rule, right, which is your physics of the simulation, and you just apply it over and over again. So matrix, apply rule, different matrix, right? And it creates a pathway of causality in that world that's basically identical to the way we currently model physics in this world. But great. Now, what happens if you pause that simulation and then restart it? What does that feel like to the simulated person in the simulation?
Well, presumably,
you can know what it feels like.
Right. If the feeling is kind of localized within the simulation, if you cease the simulation and restart it, the person within the simulation wouldn't feel anything because it's a new instance of a simulation, right?
So if you were, okay, a person's sitting here, right? And they're saying, I know there is an external world out there, And I know that we may or may not have the simulation stopped and restarted or not, okay? And they're sitting there thinking, oh, has it happened now? I know it would happen if it did, right? I would feel it. Are they correct?
Well, if all of their awareness would cease when the simulation ceases, then that's it. We can't even conceive of what it would feel like to not exist or to be dead, because that would be an absence of any sort of awareness. It wouldn't even be this idea of, oh, you're floating in a void. There is no void. There is no sensation, no memory, nothing. And presumably that's how the person in this instance of simulation that is ceased would, I wouldn't even use the word experience it, because he would not experience it. So if you have not experience as a single verb, that's how I would refer to it. But it's analogous to what I think happens with the death of the biological organism.
Okay, well, let's think about it this way then. If something's actually real, right? Or meaningful, right? Especially with such an important thing as identity, you ought to be able at least to retroactively determine whether it was broken or not. So let's say that this person sits in a room and either the simulation will be stopped or it won't be stopped, okay? So it's either stopped and restarted, or it's just allows to continuously flow, right? An hour after that, and they don't know which one happened, they're very concerned, because they want to know if their I-ness is preserved or not. All right. They're very worried. You would certainly be very worried yourself if you're in this situation. And so you seek to somehow determine empirically what the fact of the matter is as to whether your simulation was stopped and restarted or not. Within that simulation, is it possible to do so with any empirical method?
So I would say if your I-ness has been preserved, then you would be able to consider retrospectively, how was it preserved? Why was it preserved? If it wasn't preserved, then it's not you who is doing the consideration. So if there were a copy that was instantiated somehow, and that copy now has a different I-ness, and that copy might think it was you, so retrospectively, that copy might say, oh, sure, that's me. But the I-ness of me prior to that disruption, whatever it was, is no longer there. So that to me, from my current vantage point, or to that simulated person from their vantage point prior to the interruption of the simulation, it would be like another person. So whether that would be the new I-ness that thinks it's me, or thinks it's the simulated person, or if it's Dan, and Dan was there all along, and Dan is continuing to be himself and lead his life, I have as little access to that new I-ness as I would to Dan. Well,
okay, but you have a person now, right? After this hour has been done, there's a real person here in this simulation, right? And they're a real person, and they're very concerned about what happened. What can they do? What recourse do they have to figure out whether something precious has been lost? They're worried something precious was lost.
Right.
How do they detect it or not?
Right. I think they have to look at the physical processes that transpired and figure out, from the standpoint of essentially how much disruption there was. And that includes, of course, reference to biology, to neuroscience, what happens in that set of transformations, and what stops, what keeps going. If it's a simulated entity, of course, we would need to know which of these underlying processes in the physical hardware need to keep going in order for that instance of the simulation to be running.
Well, hold on a second here. It doesn't matter what the physical hardware is. What matters is there's a matrix that defines the world. There's a set of rules that define how the matrix evolves over time. That's it. Any hardware running that's going to be able to evolve the matrix over time. So the hardware is not even necessarily relevant to the person, right? I'm saying within that world, how do they figure out whether they were paused or not?
Well, that is an interesting question. They'd have to look back at empirical records and see what happens, see
What record could they
sequence of
look at
steps
that would tell
transpire.
them?
Well, if they thought that, if they knew that they were a simulated entity and the simulation was running before and then it stopped running, they could have some sort of log, hypothetically, that would give all of the prior states of the simulation. I would presume
But that would
in
come
a
from
future
outside
world.
of the simulation. I'm saying within the simulation, what can they do?
Right. Within the simulation, I mean, if they're entirely locked into the simulation and they don't have any recourse other than what they can observe within the simulation, they'd have to somehow look at the states within that simulation and which of those states are tenuous and which of those involved a disruption, and if so, what was the nature of the disruption, essentially.
Well,
So
I already described how this world works. It's a matrix,
right.
And every femtosecond is the update rule applied to the matrix, right? And what I've done is, instead of applying the rule from billion and 0 to billion and 1, instead I didn't apply that rule and I waited 100 years and then I applied the rule, right? So any observation of the outside world is not possible, right? It would be a miracle. It would literally be a miracle. It would be a way that the matrix evolves. It's not determined by the mathematics of it. But you're saying that even in such a mathematical system, you can have a conscious, real person that's a person in every respect, okay? So I'm saying, how do they tell what's happening? If they're measuring an ion moving from one point to another, right? Or they're measuring their blood flowing, okay? All of those things, you didn't stop time really so much as just stop the computation that creates time in the first place. So, let's say you were looking at a clock really carefully, right? And you were waiting for some glitch to happen. Like you thought maybe the second hand of the clock would twitch or something, right? Would you see that under this circumstance?
I mean, you wouldn't if you were stopped. But the difference between that matrix, so in that matrix, you're pausing the entire matrix, essentially. So there's nothing, if you as an external entity outside of that matrix pause it for 100 years, the next iteration of that matrix will happen whenever it happens. And to someone within that matrix, it's just as if it happened in a second rather than 100 years. The difference is we inhabit a world with a lot of other processes, a lot of other entities that continue to function, and various events continue to happen. So if you wake up, say 100 years later after some sort of stasis, you'll notice a lot of things have changed. The world has changed. And in the meantime, you had this interruption. And so the question is, you can look back and examine what was done to you in a way that could give you some clues as to whether something was preserved or whether something was lost. I mean, it's the same with general anesthesia. I have been under general anesthesia twice.
We're trying to get away from the biological details here because it just confuses things. I'm trying, if you really care about this I-ness and it's some important core part of your identity, first of all, I would assume that you should be able to simply think and meditate on yourself and the nature of yourself and feel if something's wrong. Like that's how I would expect something.
If I'm understanding correctly, though, Robert, he's already agreed that tell me if I'm wrong, that the copy will incorrectly assume that they are the original. Is that correct?
Yes, I think often the copy, if the copy isn't adequately instructed as to this philosophical view on things, will have a natural inclination to think, I must be the same person that went into this preservation procedure, because they'll have the same physical composition of memories, or at least a simulated version thereof.
Well, I think they'd be really distressed, right? If they're a copy of you, I think that would be the central question as to, am I still me or not, right? This isn't just an academic thing. They really care about this a lot.
Right. Well, a copy of me would care about this, certainly.
Right.
Now, if we take a copy of John Smith, some random individual who hasn't been participating in these discussions, John Smith might have a very different worldview. John Smith might think, well, I'm still aware and I still have my memories, so the procedure might have worked. Or John Smith might be more theologically inclined and think, I must be in heaven now. So it does depend whether a person cares about this, what that person's philosophical background is.
It very much does. A person's identity can extend outside of themselves and be bound inextricably to their environment. If someone goes 100 years, and this is a lot of the fear of it too, if someone goes 100 years into the future, in some ways they're a refugee from where they were before. Some people consider their identity to be preserved under such a scenario. Some people don't. What happens if you go 200 years in the future and your church is gone, or your family's gone, or your country's gone? Maybe you don't feel like you're you anymore. And one of the things about being us is that you do get to define what your identity is. But there's a difference between what I would call ritualistic identity or fictional identity. And it's still very important, right? It's the basis on a lot of people's identity. And this more empirical identity, right? The difference being that if you think you can feel the violation of a ritualistic identity without some physical backing behind it, you're just wrong, right? So in this case, if you say that I don't want to be copied, right? You can have a moral opposition to it. You can have an ethical opposition to it. You can have a spiritual opposition to being copied. The same way that a Jehovah's Witness might say, I don't want a blood transfusion because it'll cut me off from the body of Christ. Okay. I don't want it. All right. If I had that, even if I never knew about it, even if it saved my life, it would be wrong. Okay. And it would have disrupted something precious. Right. And that's something you can believe, but it's not something you necessarily can access other than as a personal belief. Does that make sense?
Well, I do want to posit a key distinction between this ritualistic version of identity that you described and the I-ness concept, in the sense that I-ness doesn't depend on any particular content of one's consciousness. So somebody could experience complete amnesia and still have the same I-ness. And this happens at times to people, and then they might regain their memories, but even while they have
that is correct. Being part of the body of Christ also doesn't depend on the content of your consciousness either. If you're saved and you lose your memories, are you not still saved?
So I will leave that to the Christian theologians, since I'm not one of them. But hypothetically, let's say one were abducted by aliens, and the aliens took one to a very different world, another civilization where one feels like a complete stranger, outcast, doesn't know anything that's going on, but still one retains the same I-ness. It's just one's I-ness is now in a weird location.
I have to object, because you're asserting that they just know that they have retained their same I-ness, but you have at the same time agreed with Robert that the feeling that somebody has that they have retained I-ness can be an error. So you can't have it both ways.
Well, you can have it in different ways at different points in time. So going forward from second x to second x plus 1, if you experience this continuity, you can say, okay, the person at second x, if you are some sort of reinstantiated entity at second x plus 5,000, then you don't necessarily know if the entity at second x was preserved, unless you have some good evidence to believe that. So looking forward, if you experience continuity, you can be pretty certain. Now, the issue is, if I didn't have continuity of my I-ness right now, the I who and talking to you right now wouldn't be experiencing anything. It would be that non-experience that we discussed. And it's very difficult to talk about because the language isn't really equipped to describe it. But
I think the key question is, what is the nature of identity? And if you accept that identity is in terms of memory, which is information, which is independent of substrate, then it's whether the information, whether you exist at a given point in time, is not a question of whether your brain exists, but whether that information exists in some form. And so, would you agree with that?
Well, I think you've outlined.
It sounds like you're almost positing an additional thing,
right?
But then the question is, empirically, what is that? Because information,
so you can pause an additional thing. It's perfectly fine to pause an additional thing. There's nothing wrong with saying, if my church isn't alive anymore, I'm not me anymore. Okay, it can be external, right? But if you want it to be not purely ritualistic, right, then you're saying there's an empirical component to it.
Right.
I'm saying the thought experiment with the digital person that disappears and then reappears, right, with a break in the simulation, right? I've described a perfect cut in the time of this world that's undetectable. You can certainly say, look, I'll never know if my time was cut like this, but ritualistically, I hate the idea of it, and I don't consider myself to have survived such a cut, right? You can absolutely do that. You can believe that very strongly. Nevertheless, it's not possible for you to detect such a thing. What it feels like afterwards is the same as it would feel like if it hadn't happened.
So it's a distinction between a kind of pattern view of identity and a process view of identity.
There's no distinction here.
The idea.
Like simulation.
I mean, the way I frame it's a little differently, because I'm saying, so when you do the cut, the person still exists because the information was preserved during the time you're doing the cut, like your time you stop the simulation. That memory, that information is in the hard disk, so to speak, somewhere. So there is a continuity in that sense. And that's where I have trouble understanding Gennadi's view, because for me, there's continuity if the information is preserved. But Gennadi seems to think, and when you do a destructive uploading, the information is by definition preserved. It's just changes substrate.
Well, but you can say you can simply assert that isn't kosher, and you don't. And
to me, that is a continuity. A discontinuity would be if the information was irrevocably lost.
Right, but you can say your identity depends on not having a non-kosher thing done to you, right? That's a critical part of your identity. And if one of the things that you think is not kosher is anything,
right? So that's why I'm saying the way I'm framing this is the question is really identity. That what defines you. You get to
but it's not arbitrary.
The reason I have trouble understanding Gennadi is he's positing this I-ness, but it's hard to nail down empirically what it is and what it is.
It's not arbitrary. It's not arbitrary because it does require certain physical prerequisites. So I'm not the kind of person who would posit like a dualistic soul that exists outside the body. I'm specifically saying there has to be a certain set of bodily processes that would essentially continue and be the prerequisite of this emergent property of consciousness. And it is very much the case that you can't just have the body be destroyed and then some sort of soul or some sort of ethereal existence continue on. I think based on what I get from Ken and Robert, you're also both physicalists in that sense, and that you would agree if the brain and the body were completely destroyed, there's nothing that just persists beyond that. Correct?
If there's a copy somewhere, you can't answer the question unless you know that all the copies have been destroyed. So I'd actually argue no, if there's another version of you running around that's an identical copy,
from a physics,
you don't know.
There is this idea in quantum information that I think that information cannot be destroyed. But
but yeah, that's not the same as a person being destroyed or not.
I guess that's not really.
Yeah. No, I'm
we're
literally
talking
saying
about-
if there was a backup of me, right, somewhere, which we know there are no backups right now. There's nothing that naturally creates them. We don't have the technology to create them. I'm saying
Right.
one of the consequences of this sort of very physical information-based theory of identity is that you have branching, and the branching is it's just a feature of a thing that can happen, right? But what that means to you, you get to decide on your own whether you personally think that that's kosher or not with your identity. Nevertheless, after you've then decided what your own internal kosher rules are, I can tell you what it will feel like under certain circumstances, and there is a fact of the matter to what it feels like, right? So that's kind of how this works. So when people say, are you still the same person after being uploaded? It's actually pretty complicated, and it depends on what you personally believe about uploading, which is kind of strange. You would think there'd be a complete answer to it or not. If you want to know what does it feel like to be uploaded, I can tell you what it feels like. It's indistinguishable from going under deep hypothermic circulatory arrest and then waking up from that. It's a jarring sort of discontinuity, but it's no worse than that if it's done properly. And in fact, if you had gone under DHCA, right, and then you were either teleported in place, disassembled and reconstructed, or just allowed to continue to wake up, it would be virtually impossible to empirically determine which of those cases it was. And so any further consternation you have about the process is more about ritualistic identity and less about anything that's strictly empirical or measurable, right?
So this is where I have a hesitation, because let's say you continue to exist while there's a non-destructive upload of you or a physical copy of you.
Absolutely.
However,
the
they're
branches will
instantiated.
screw your mind up, right? But here's the thing: people do get into branching situations currently today. It's interesting. So if you are blackout drunk, then your brain is no longer capable of consolidating memories. If you have a very high alcohol tolerance, you can still be reasonably functional, even where you've now exceeded a level of alcohol that you can't consolidate memories anymore. So during that time, it's like you're a separate person than the mainline branch of you. You're going to go to sleep, but once that memory consolidation blockade is in place, everything that happens and everything that you experience will be erased once you go to sleep. And the version of you that wakes up is like this discontinuous jump, right? Where before you were blackout drunk, you have memories, then there's some period of your life that's been snipped out of your timeline, and then you wake up, okay? Now, what do people say when that happens to them? They say, I have now suffered from memory loss, okay? And that's unfortunate. What do people do when they are blackout drunk? They don't even realize it. They just keep going and doing what they're doing. Now, certainly you could have a notion of identity that says, because there's this discontinuity, right? That person that is in the blackout drunk stage, they're going to die when they go to sleep, right? They don't have any continuity. And they should be very worried about this. And, maybe if people thought about it, they would be more worried about it. That person really does operate like a different person. You can write yourself a note and be genuinely surprised by it. You can hide things from yourself like another person can and not know where they are, right? But they are a copy of you. They've got all of your memories. They work the same way. So I would say that it's only a ritualistic idea, right? A kosher law that separates how we already treat being blackout drunk to how we would treat having a copy of yourself made, branching for a small amount of time, and then disappearing. In both cases, you have, for a brief amount of time, a person that's a copy of you walking around independent of you that you don't share experiences with, doing their own thing, and then going away, disappearing, right? If you label one or the other death or memory loss, that's more up to you, but it's just a definitional idea. It's not really a strictly empirical idea in that case.
Now, I do see a key difference here in that it is the same physical substrate performing all of these actions. It's just the content of consciousness gets erased because of some faults, let's say, within that physical process. It's the same as my example of amnesia. So you could lose all of your content of consciousness temporarily or permanently, but retain the same I-ness. On the other hand, you could keep all of your content of consciousness. Well, it could be reinstantiated in some other format, but unless there is a kind of stepwise transition where you can follow each step and say, okay, this is where there is a continuity, then you lose something, you lose that process. So I would say it's possible under certain circumstances to have mind uploading or replacement of the brain with some artificial brain that preserves I-ness, but you have to kind of incrementally graft artificial neurons onto the biological brain in a way that the artificial neurons interface with the biological brain. And then essentially, from a forward-looking perspective, you still have the same process operating. The content could shift radically. You could forget something, you could remember something, you could learn new things. That happens all the time. The physical components could also change as well. So we ourselves turn over our atoms and our cells on a fairly frequent basis. I believe at least most of the human cells in an organism are not the same 7 years after a given point in time.
Well, that's
so
not true. Your
it's a
neurons
kind
are
of
the
ship
theory
of
of life.
Theseus. Okay. So then,
and a lot of osteocytes are too, and even the molecules like the DNA in your neurons.
A lot of the other parts.
Yeah, but
Okay.
Now he's just saying he's comfortable with that. What?
Right.
What
so
would
this
you
kind
not
of
be?
incremental
But
turnover
you're
within
not.
this
I don't
process.
understand why you're comfortable. For me, like uploading would be similar. It's just you're replacing things all at once, essentially.
Well,
So,
I'm not comfortable with that in the same way as I wouldn't be. In the same way that I wouldn't be comfortable with, say, I kept my biological body, but my brain got taken.
Oh, you paused.
Oh, we lost him. Well, okay. Well, while he comes back, the question is why. So you may even lose something, right? There may be something that's lost if you're copied, right? There certainly are physical changes that happen. But the question is, why do we privilege these physical changes and value them? What value do they have? Why do you choose to make them such an important and critical aspect of your identity when it's possible for them to change without you even noticing them? To me, something that is a critical foundational aspect of my identity that I'd be upset if I lost should be measurable, should be detectable. Maybe I should just be able to realize that it's gone and be upset immediately, right? But maybe if it's damaged me so badly that I don't know who I am anymore, I wouldn't even notice. But certainly my family, my doctor ought to be able to recognize that. But this idea of something that can't fundamentally be detected in the extreme case and is virtually irrelevant in other cases seems to me like it's kind of a dumb thing to privilege. Like it doesn't really do, what do I gain from defining my identity on those terms? I can, okay. Like I can define my identity where if I ever get a blood transfusion, I'm not me anymore because I'm not part of the body of Christ. But why would I do that? Why would I deprive myself of blood transfusions? And you might say, how would you convince someone who really believes this that no, it actually doesn't destroy your identity to get a blood transfusion? You'd be wrong. It does destroy their identity to get a blood transfusion. Someone who believes that if they were teleported with a Star Trek trial transporter, that they're not them anymore, if that's what they really believe and you're an asshole and teleport them anyway, then you've done them great harm. And if they find out about it, right? If they think that they would somehow feel it, right? They're wrong. If they can think like, oh, I know I was teleported, I know I've been disrupted and I hate that, they are wrong about that, okay? That doesn't mean you're a dick, you're not a dick for teleporting them. But then the question is, and the way I would argue that someone maybe should choose not to have that be a critical part of their identity is, you can't even tell if it happens. Like, what good does it serve you? What if you have a definition or a value that you hold, it should serve humanity or it should serve yourself, right? It should pull its weight. Any sort of ritualistic idea of identity, I believe, should pull its weight for you, right? And something that only exists to deprive yourself of the use of technology and doesn't give you any sort of compensating benefit, to me seems like it's suspect. Like, why is it such a critical part of your identity? Right?
Can you hear me now? Am
yeah,
I back?
I can now.
Okay, great. So I'll answer these questions in sequence. First of all, I would be comfortable with incremental replacement of parts, including replacement of biological parts with artificial parts that are functional, integrate into the rest of the organism. I wouldn't be comfortable with a wholesale ejection of my brain from my head and replacement with a positronic brain like that of Mr. Data from Star Trek, even if hypothetically that brain had all of the same content and all of the same functionality, because my I-ness resides in that biological brain. Now, that biological brain could be altered over time, but if you take it out and put it somewhere else or stabilize it with glutaraldehyde, and then this positronic brain resides in my head, I'm not going to be aware of what my body with this new brain is going to experience. But in terms of the importance
hold
of
on,
this,
hold on a second. I can't let you say that. When you say I'm not going to be aware about it, what I understand you saying is you choose to interpret that as a type of death rather than a type of memory loss or a type of transition. And you can choose to do that, but why do you choose to do that? You don't have to do that.
Well,
what value does it bring?
Let me use these fists as illustrations. So these are two brains, except this one is biological, this one is positronic. This is the one. This is the one that my current I-ness essentially resides in, along with my body. Good. So put this one in my head instead. That one's over there. It's preserved in glutaraldehyde. It's not aware of anything anymore. This one is it's commanding my body to do things. So my body is walking around. It might be indistinguishable to an external observer, but that's not my own awareness anymore.
Hold on,
I'm fixed in glutaraldehyde.
Hold up a second here. Hold up. We've already also agreed that it's not only indistinguishable from an external observer, it's indistinguishable after the fact from whatever's left in this transition. That thing can't easily tell whether it had been transformed. If God somehow reached down and miraculously replaced your brain right now with a positronic brain, right? So quickly you couldn't even detect it all at once. You wouldn't notice, and we wouldn't notice either.
You wouldn't notice that this is true, but let's say
would not notice.
Right. Let's say, contrary to all expectations, the glutaraldehyde preserved brain 1,000 years hence had the glutaraldehyde fixation reversed. And all of a sudden it got reinstantiated to another body. Now, there would be questions from my standpoint about whether that preserved my I-ness as well. But let's say that individual then looks at the person with the positronic brain, and the person with the positronic brain was around for that entire millennium. He was able to accomplish a lot of things, change the world in noticeable ways, but the person who wakes up from the glutaraldehyde preservation is going to be thinking, what happened? Wow, this is surprising that this other entity did all of these things, but I wasn't aware of it at all. I didn't experience it at all.
That's right. It's a fact of the matter that because we're information, you can be branched. A person can branch and exist in more than one place at a time. And of course, there's no way that they have some connectivity between them. But you have a choice to define your identity as thinking of that as essentially there's memories being accumulated in different places that don't communicate with each other, or to have an idea that there's one sort of I-ness that follows around more like originality in painting would, right? And the other ones are false pretenders, right? That have no value, or at least have no relation to you. But that's a ritualistic choice that a person can choose to make or not. It's not an empirical one. And so why not choose the one that actually benefits you and doesn't constrain you? What value do you get from treating yourself in this way? Or thinking yourself in these terms?
This is, I think, the empirical difference. And this does have a bearing on the choices one makes. So the current argument that I've heard regarding how this brain preservation would be performed would entail some sort of elective euthanasia, essentially, which would make me quite uncomfortable, because I believe I have my I-ness now. So even if I have some terrible terminal illness and am losing brain content, I'm losing memories, at least I have some sort of vestiges of awareness of the world. So I want to perpetuate that for as long as possible. Here. And so
okay, I'm gonna flip you around. So now you're in my shoes, okay?
Okay.
There's two examples here. You can pick either one you want, all right? So you have a person and you snap a photo of them on your phone, and they now understand that you have taken their soul and captured it. And they're very upset about this, okay? What do you say to them, okay? Or the second one, if you'd like, is, there's some people that genuinely are terrified of the idea of anesthesia. Exactly as you feel about this break of continuity you get with mind uploading, they feel the same thing about anesthesia. They think that the anesthesia would wipe them out, and then would arise a pretender, okay, from this broken bit in their personal timeline that would take over their life, have sex with their wife, raise their children, take all their money, and it's a competitor. It's not you, okay? Maybe it's a kind of more sophisticated version of the mirror test that we give to organisms to test their intelligence, right? Can you recognize something you or not in the mirror? Well, they don't like anesthesia. In fact, they're considering having a surgery, okay? Well, they need a surgery, and they're going to die if they don't get it. But they're thinking, well, maybe I'd rather die than go under the anesthesia. And what do you tell to that person? How do you convince them to have a different idea of their selfhood?
Right. So for the person who's afraid of the camera, I can say, look, this is just a static image, and I can draw a static image of you if I have sufficient skill to do that. But ultimately, it's just a physical process that captures certain phenomena of light and creates an image that looks like you.
And they agree
but
with
it's going to interrupt.
Yeah.
It's not going to interrupt what you're doing, how you live your life, what you're capable of doing in the least. So that was easy. With anesthesia, my argument would be continuity of physical processes. I would say, look, even though you experience an interruption of your conscious awareness, maybe not. Some people have actually reported dreaming under anesthesia or being fully aware, but let's say that's not the case. In my case, I actually did experience an interruption for a few hours. Not experience an interruption, to be technically correct. I remember going under, I was talking about the economic thought of Adam Smith with the surgeon. And then the next thing I remember, I woke up and I saw essentially some of the images from the procedure kind of on the wall in front of me, and I realized, oh, the procedure is over now.
I was so mad when I was a kid because they gave me anesthesia and they said, oh, we'll count down from 10. And I was listening to them count down, and I wanted to feel, what it was like to get it. And then around 3, then I just black out. And I was mad at them because I thought, oh, these assholes, they did it, at 3 instead of 0, like they said. And 20 years later, I finally realized, no, they did do it at 0. And my memory was retroactively erased because of the effect of the anesthesia, right? Because that's how that actually
And that's
worked.
Interesting.
Anyway.
That is indeed interesting. And you could have memory erasure of something you hypothetically experience immediately prior to the anesthesia or even during the procedure. But the argument that I would use to comfort an individual who's worried about it would be to say, look, this isn't putting your entire body on hold. Your heart is still beating, blood is still being supplied to your brain, your lungs are still taking in air, other organs are still functioning. So there's no reason to think that there would be some radical break with your past and with your I-ness just because you essentially went into a very deep sleep for a while.
All right. I can go 2 ways on this, but I think the more annoying one is, fine, like it's DHCA. All right, we're gonna, like we've done for 60 years, we're gonna drain all your blood out of your body and replace it with saline and cool you down to 10 degrees and turn off the pump for 2 hours while we do surgery. So you're not going to have any heartbeat. You're not going to have any brain activity. You're going to have basically zero respiration. It's all going to be from the whatever oxygen you happen to have before, and then we're going to pump different blood into you from somebody else and warm you back up. And here's 30 people. They're all good. They said they're good, and their families said they're good, and their bosses said they're good, and they're scared, and they think they're going to die from that because they care about their continuity. What do you tell that person?
Yes, I would say that's a very interesting case, possibly a borderline case. My intuition suggests that I-ness could be preserved under the circumstances, because all of the structures are essentially preserved, with the exception of anything that's modified, but it's not modified in any destructive way. So they fix whatever the problem is, and the new blood, even though it's not the same blood, you could get a blood transfusion. As long as the blood does the same work, you would have a good chance of preserving the I-ness.
Now,
now they simply assert to you that they don't care about that. They care about continuity of mental experience.
If I might interject, what I'm seeing here is that Gennady cares a lot about preserving the structures. But you would agree that that identity is, you do agree that identity is substrate independent at the same time, because you said you agree with the ship of Theseus.
No, he says conscious.
Right,
I guess, right. Yeah, that's true. Never mind.
So to me, if you accept substrate independence, then you shouldn't have any problem with having your brain shifted into a different substrate. Now, with branching, I think that's just something we're all going to have to accept with this technology. It's uncomfortable, like having all these other versions of you, but that is a logical outcome of this. And if somebody who's interested in this, Robin Hanson is an economist who's actually thought a lot about what society might look like in the future when we have these whole brain emulations, and they could branch themselves and things like that. And that's just something we're gonna. That's just something the branching thing is something we're just gonna have to wrap our heads around. But to me, that's independent from this other concern of losing I-ness during the upload. So I think we should we need to focus on these things separately.
Right.
I mean, they're related, but to me, they're separate.
It's possible to have an emulation that has a distinct I-ness, which is in a different substrate. So I could see a situation where the same content is instantiated in a different substrate, and that entity has an I-ness. What I don't want my view of substrate independence to infer is that it's easy for the same I-ness to jump from one substrate to another.
Well, it doesn't jump, it splits.
I would say it
splits.
So you have a different I-ness created in a different substrate that resembles the original I-ness. But my question is, what changes to one's current substrate could preserve the same I-ness within it? And clearly some of them can. You could have a functional prosthetic. You could have something wired to your nervous system that is an artificial component. You could have an artificial heart. You might have an artificial neuron interacting with the biological neurons. And by the ship of Theseus argument, you could transition from one substrate to another. My contention is you have to have some sort of either continuously functioning process, or at least close enough that the interruption doesn't destroy the structures to some sort of irreversible.
So hold on a second here. Let me get back to this person who's going to go through DHCA, because the argument you gave to them, I would say, isn't really a good argument, because you argued for what would convince you that you survive. You didn't argue for what would convince them that they survive. They're worried about the continuity of their mental experience. And you argued, well, there's some continuity in their physical body, and so therefore don't worry about it. That's not a very good argument. Maybe you could try again on that one. Because they're going to simply assert to you they care.
Well,
about
perhaps there is.
Identity. Why is your idea better than theirs?
Mm-hmm. Right. Perhaps there is some sort of time buffer so to speak, during which brain activity might cease. But if there is enough preservation of the structure, it could be restarted still as the same I-ness. Whereas if you wait for a long time and the contents of the brain decay, or you just wholesale import the contents into a different substrate, but you never revive the original, it would be too much of a discontinuity to preserve that process. So that's how I am tentatively looking at it, tentatively because I would need to be more familiar with the mechanics of the procedure to actually be able to tell you exactly where I stand on it. But intuitively, it seems to me, if you put the brain on pause without destroying it, without damaging it, and you still have the ability to just fully restore it to functioning, that should preserve the I-ness. But that's because there may be some built-in time buffer. It's not like the matrix entity where time is digital for that entity. So, so every moment in its existence.
Yeah. So I'm this person, and I
every
say,
moment,
look, I define
right.
my I-ness to be continuity of mental activity. Okay, I'm okay with sleeping because I still have mental activity. All right, and there's no question that that mental activity is disrupted by DHCA. So therefore, my I-ness is disrupted, and your argument is bullshit. And you know, it's unfortunate that I have to die because, you know, but there is no other way to do it. Now, I would accept that they could do this operation while I still have conscious experience, right? If they could figure out how to do that, then I would accept it, right? But I'm not going to accept what you're saying. Now, I don't think any of the arguments you presented would work.
Let's give Ken a chance.
Yes.
Yeah.
If I can translate for a second, I think what Robert is saying, and it's probably obvious, but I think what Robert is saying is that you're using the term I-ness, and you're using it in a way that seems completely insulated from any real empirical knowledge. There's no way that we could get to the bottom of this I-ness that you're talking about. There's absolutely no way. And so we're left with, we can define I-ness as we care, and you have to take everybody's I-ness as being equal, as Robert is pointing out. If somebody says that their, you know, the lack of continuity of consciousness from an anesthesia is going to somehow magically destroy my I-ness and replace me with copy, then we have to just say, okay, that's fine, because there is no way to define this. And I challenge you, you know, allow anything that we can do in the future to get to this I-ness. Is there any experiment that you can imagine that would narrow it down, and we could say, there it is, right there in the process? And if you allow this process to stop momentarily, the I-ness is gone. How would you ever know? You're basing, and the reason why you're doing this is because you're saying, look, there cannot be branching. There cannot be branching, and therefore I have to find something in physics that tells me why there's no ability to branch. And that is a very bad way of arguing backwards. But go ahead. I want to,
right.
You know, is there a way to get to I-ness?
I don't think it's one process. It will probably be a set of processes that have parallels in various substrates, so it would look different depending on what the substrate is. I do think we can get to it, but I think it requires a combination of empirical observation and introspection of the sort that I was able to perform. If there were no direct conscious awareness, direct conscious experience, then I wouldn't be able to make statements like I went to sleep, but my I-ness wasn't destroyed by that, or I went under general anesthesia and my I-ness wasn't destroyed by that. So the key is to.
You've already said. We could be clear.
Yeah, you can't go back to that.
You've already said that you can be wrong. You could be a copy and not realize it. Okay, and so saying that, oh, there might be some way that we could introspectively figure out that I-ness has been lost, you've already given that up in the argument, I believe.
So I don't think I could be wrong about this. I don't think I'm a copy. And I know this because I wouldn't have any conscious experience whatsoever. I wouldn't have any subjective experience if I were destroyed and a copy were in my place. So
Exactly
I would be as little aware of this conversation as I would be of a conversation among completely different people whom I've never met, who might be talking
So
right now.
you're saying you know whether God stopped the universe last second, waited an eon of contemplation, and then started it back up exactly it was. You know for sure whether that happened or not.
Well, I don't believe in the existence of a God that could have that ability. So in this present universe, where I do believe we are all biological entities, not centrally controlled, I would agree. But I do want to address some of the other questions that have been raised in the chat. And I think one that I want to go to, because it is relevant somewhat to this discussion, is from Alexandria Black. She asks, how well do we understand quantum effects in the brain? Can we copy a brain without full understanding of this? So what are your thoughts about any quantum effects in the brain or
Lord
on
Christ.
consciousness?
Look. Your brain is warm and certainly, of course, uses quantum mechanics to exist the same way that the fibers in a bird's wing need quantum mechanics to fly, okay? But modern neuroscience, okay, does not say that quantum mechanics is used to store information or do computations. As far as we understand, the brain uses biochemistry to do computations and store information, uses nanoscale structure. So because of that, then there should be no problem copying things. I understand there's this idea of a no cloning theorem in quantum mechanics. Some people take that to mean you can't genuinely copy anything to anything, or there's some sort of real concept of authenticity that's blessed by physics that adheres to things. It's almost like exactly the opposite of that, but in reality. But it doesn't matter because the brain exists at a physical level, and the mind exists at a physical level so much higher than quantum mechanics that that detail of the universe is irrelevant. And to demonstrate that, the mere fact that you can do DHCA on someone, right, cool them down, I mean, there's a lot of very dramatic physical changes that happen to a person when that happens. Your extracellular space is lost, your neurons all depolarize, a lot of your microtubules disassemble because they can't stay cohesive below 10 degrees Celsius. Doesn't matter, okay? Your brain will figure it out and get you that. It's good at that. So no, like it doesn't matter. Quantum mechanics is not relevant to this and won't be relevant until we're building quantum computers that have AIs on them that genuinely make use of quantum calculations. Then they can worry about that. Those AI minds can worry about that because they may end up with a situation where they would have some trouble copying their memories from one place to another in certain circumstances. But humans
this is
are
why
not
we can't build in order to have a coherent quantum state where the quantum properties are preserved. It has to be very it either has to be an isolated particle or a system at extremely low temperature. And when you have a particle interacting with the environment, it loses that those quantum properties. That's why it's so hard to build a quantum computer.
Yeah.
And this is very well known in physics. And so, if you're not familiar with quantum physics, you can look up decoherence and this sort of thing. It's very well established that it's impossible to have an extended quantum state in a warm body with many interacting component particles like the brain. Now there are some minority views like the view of Roger Penrose and et cetera, but those are very tentative, unsubstantiated claims at this point.
So here's the other thing here. To get back to what we were talking about before, this guy who's worried about going under DHCA, the best argument I would use to convince that person, because I would very much care about them surviving, okay, is I would say, look, it's very scary to go under DHCA, all right, and you're worried about losing something precious. What I can do is I can point to these other people that have undergone DHCA, and as far as we can tell, they survived that and they still feel like they're them. In fact, they can't tell that they're not them anymore, right? And their family can't tell that they're not them anymore. So while respecting your idea of what your I-ness is, I would point out that it's not serving you well, okay? And you really can choose to think of yourself on different terms that are compatible with survival. And it doesn't really cost you anything, right? If you consider that the continuity of your physical body, right, and that these processes in your brain will start up again like they were before, it's really not that much different from going to sleep or going under anesthesia that you're already okay with to really worry about it very much. And if you choose to treat yourself or think about yourself in terms that would say that you die from a process that you couldn't even tell it happened or not, right? Because going under anesthesia or going under DHA feels the same to you, why are you choosing to make such an important distinction about this physical effect, right? I understand it's a little physically different than it is before, but you can choose to make that a significant part of your life, or you can choose to make that an irrelevant part of your life, right? And if you're going to choose to make it a significant part of your life to the point where you're willing to die over it, then that belief ought to pull its weight. It ought to give you the same benefit equal about to your entire remaining life. And if it does, then maybe that's okay with you. Like, for example, if you're part of a religion, your religion says you can't do DHCA or you're going to get excommunicated, and you consider on the one hand the loss of your family, the loss of your church, the loss of your community, potentially the loss of your job, and generally people being upset at you, versus being part of your community and going out as a faithful part of that religion, maybe that's worth it to you, okay? Because it happens to be something that's important for your community, but it should be of similar importance to that. And if it's just because you're worried about the philosophy, it's tough, but there are people that see themselves in different ways, and you don't have to see yourself that way. That's what I would argue. And I'd probably lose and they'd probably die, but at least, I'd try.
Well, I can appreciate the consequentialist argument in terms of what are the benefits and risks of either decision and what is the worst that could go wrong. And in those cases, I would select the DHCA procedure if I were to be given an option. Let's say it was a costless option from a monetary perspective of cryonics or even glutaraldehyde brain stabilization after legal death. I'm okay if legal death is inevitable under the current definition, and after I experience it, I can choose either nothing or those techniques. I would choose those techniques. Where I think the consequentialist argument falls apart is if there's any kind of, let's say, necessary acceptance of what would be considered death today, clearly, in order to take advantage of some probability of future reinstantiation. So I would never accept collective euthanasia under any circumstances, because I know I have this I-ness now, and if I were to have a degenerative brain disease, well, at least I could live with it for another certain number of years, perhaps. And then after that, after all other efforts to preserve this I-ness had failed, I could be at a point where I would say, okay, what do I have to lose after I'm declared legally dead? Preserve me as you will.
Well, the other thing I would say is that choosing to conceptualize yourself as an information construct that can branch is amazingly liberating and amazingly powerful. It gives you abilities that are simply impossible under any other conception of yourself. Among them include the ability to truly be immortal, because you can make backup copies. And it's only by making backup copies that you can genuinely keep a piece of information alive for an indefinite future. The other thing that it does is it frees you to travel at light speed. If you really understand your identity on these terms, you can go at the speed of light. You're not bound by material constructs anymore. And so conceiving yourself as on these terms is immensely beneficial to you. I would say it gives similar benefits to conceiving yourself as someone that can have a blood transfusion, right? That also gives major benefits to you. And believing that you can't have blood transfusions, it doesn't pull its weight as a belief. It's not serving people well. So, you know, all beliefs are not equal. They ought to pull their weight from a humanistic standpoint. Or, you know, at least I think that's one reasonable framework in which to evaluate beliefs.
Well, they need to pull their weight from the standpoint of empirical evidence to support them as well. So somebody might say, you can join this particular religious organization, say the Heaven's Gate cult, and if you do certain things, then your mind will be liberated to travel the stars with this alien species, but that's not what happened from a scientific
standpoint. Well, we're not disagreeing on the empirical facts. So
right.
no one here is, that would be a case where you're just lying to someone.
Right.
We don't disagree. You agree with me that if you take a brain and you scan it at high enough resolution and you create a computer program that approximates the original, it'll behave the same way. We don't disagree.
It's a bit subjective because
the question is, how do you view yourself?
Right. The outside observer wouldn't notice any difference. And the other point I was going to make was, there's also a very compelling argument from a lot of Eastern philosophers and philosophers like Sam Harris and others, that the self doesn't even exist. I mean,
well, of course, I disagree with that. The idea of a unified, coherent self is core to my view. But go ahead.
Well, right. Well, there is this whole other view that some people have that the self is sort of an illusion, and actually there's just one physical reality that's sort of all evolving and over time as a sort of an interconnected whole and such. So there is a lot of different views on the selfhood and the nature of identity, and so I think that I like this frame that Robert's working in, where we're trying to pin down which of these are the most pragmatic, so to speak. At the same time, but there's another frame which would be the external, like, could an external observer tell that any difference? That's another, I don't know.
External, or could the person introspect and determine whether it happened to them or not?
Well, it's interesting because there's a comment that was just posted by Sergio Terrero in the chat, and he says, quote, "I've thought of Gennadi's I-ness from the point of view that you could make copies of the original person, but so long as the original person is alive, it's a different entity to any future copies. Thus, it could be argued that the copies are not you at all." So let's reverse perspectives here for a moment, because I understand that I've been talking from the perspective of the person prior to the copying or discontinuity, but what about the vantage point of the copy? Let's say the copy of me goes forth and does his own things, and I'm still sitting here talking to you. That copy is going to look at me as if I were some external entity as well, and that copy wouldn't be able to perceive the world from my vantage point.
Your copy would look at you as an other entity. My copy would understand the situation that we're both branches, and would consider that there's a Robert that has memories accumulating in two different places, and that if one of those accumulation points is destroyed, the loss to Robert is the sum total of the unique memories contained in that accumulation point. And that, yeah, if you go far enough, you surely branch and you can't really be said to be the same anymore, but you can merge too. If you're digital, you can split for a day and then just literally write both the memories into a new construct that has both experiences. And you wouldn't drift enough in personality for it to really be a problem. That's the other thing. You know, once you accept this idea, it gives you a lot of more powers, like being able to merge as well. And so I do think that's a fairly important thing to think about too. There's two things that are also important here. Legal, like regardless of how you personally feel about the matter, legally, we must treat copies as the same person, punishable by the crimes that are committed by any one copy. Otherwise, if I copy myself and the copy goes and kills someone and then kills themselves, then I can just commit any crime I want and get off scot-free, right? But what should happen in that case is that I should be arrested for a conspiracy to commit murder because I clearly planned to murder this guy and in fact carried out that act with something that's computationally identical to me. Otherwise, you're going to have a lot of legal problems.
But it would be just as difficult to control the actions of your copy as it would be to control the actions of your clone or your twin sibling if you had a twin sibling. Yes, they're similar to you, but ultimately in that moment of decision making, they could make a very different decision from what you could make, and you wouldn't be there. You wouldn't be able to stop them. You wouldn't be able to tell them, no, this is wrong, because whatever experiences they have after the branching could influence their decision. So this is where we get into murky territory. And I like what David
you have to argue that in
Shoemaker.
court. You have to argue, no, I've changed in the 5 minutes since I copied myself. I've gained such life experience that I'm not rightly the same person. I shouldn't be punished. And you could make that argument, and it would be more powerful the longer you've diverged. But what you shouldn't be able to do is say, that's not me. That's like a company that commits a crime or has problems and they just change their name and they said, oh, no. We already have this problem, corporate identity, right? Mm-hmm. Corporations can branch and they can merge and they can do all these complex things. And we have laws that deal with them and they treat them, I think, in a reasonable way, as we'll eventually have to treat individuals as well under these circumstances of mind uploading. And that's independent towards any definition of I-ness if you want like a functional system where people can't just get away with whatever, right? So that's an important thing to consider as well. Yeah.
Yes, and David Shoemaker made some relevant comments in the chat. He points out that an example from cryptocurrency is when a branch occurs, there's the original coin and the new coin. And prior to the branching, they essentially were the same. After the branching, they have very divergent blockchains sometimes. He also writes, he poses this in the form of a question. I-ness is in the eye of the beholder. If I believe I am me, then I am me. In practical terms, future law will decide, he writes. And you touched upon that in terms of how will future law identify the individual. I really do believe it would be untenable to hold each copy responsible for the actions of any other copy. That in itself would lead to a great disincentive toward branching, because people would think, well, if I have this copy and I can't be there to supervise it all the time, it could go forth and do things that I would disagree with.
Well, not having a law is a massive incentive to branch is the thing. Look, we don't allow Google to create Google crimes, right? And commit whatever crimes they want under that subdivision. And then when people get mad, they just like, oh, sorry, but we disbanded Google crimes now. It's not a thing anymore. So there's no problems anymore. We're like, no, there are in fact problems. And we're gonna, get the organization that it split off from.
Can I say something in this?
Yes.
These conversations go in circles, and I think that is one argument that the idea of I-ness is intrinsically not what we think. But from a brain preservation perspective, and I'm sorry, I got one. From a brain preservation perspective, there are people who
believe that brain preservation and mind uploading will allow them to survive. And to such an extent, and I speak for myself, to such an extent that they would choose euthanasia and not think of it as euthanasia. They would think of it as this is a surgical procedure that is a radical surgical procedure that I might lose my life, but it is my best chance to survive in the future. And there are other people that are strongly opinionated otherwise. And I would just argue that at the very least, it should be a choice of the individual. That nobody is so sure about their concept of I-ness today to say that somebody who believes that that brain preservation is going to allow them to survive in the future, that they're dead wrong. Pardon the pun. And so we should default to honoring the person's choice.
Now, I would say, yes, I have a strong disposition toward supporting individual choices. There is an interesting comment along these lines from Zach Richardson, who writes, if you concede that future technology is to some degree unknowable, then why should a person who is more optimistic toward future reanimation be prohibiting from rolling those dice with cryonics? And it seems to be the same argument, except in favor of cryopreservation should a person elect to undergo that procedure. Would you agree with that?
Absolutely. My arguments against not allowing people to undergo cryopreservation is more of a practical point of view, that if we back up and try to engage with the medical and scientific community, that it would give better cryopreservation and more legal access to cryopreservation in the future. It's not about me trying to put down personal choice. I think people should have the choice to do stuff like that.
Mm-hmm. And I think we can be largely in agreement on the personal choice standpoint. With euthanasia, I have some practical reservations. Those largely apply to cases where everyone knows that this will end the person's life. There's no dispute about it. At the same time, I wouldn't be one to say, oh, the government should punish somebody who takes a medical substance to end that person's life, because it would be impractical to do that. What are you going to provide as punishment for attempted euthanasia? The death penalty?
You're going to punish the doctor that gave him the medicine.
Right. And what my concern is with the assisted component of assisted suicide, because that could create financial incentives to encourage that procedure. It could create constituencies that will lobby to make it a default rather than an opt-in type of procedure. And people might argue, oh, look, it will save the medical system resources not to have to support people who are terminally ill, but we know that they're on their last legs. And this is...
It might even suggest that it reduces human suffering tremendously in general. And that would be horrible. We have to maximize suffering and prevent people from trying to reduce their own suffering. I mean, my God, I'm with you 100% on. I'm sorry. Obviously, I'm for you.
Well, I believe that there is moral value in the continuation of the life of the individual. If you see it from my standpoint, given all of the discussions we've had about I-ness, if this is all that I have, hypothetically, and especially if we're living in a society prior to those technologies, say we're talking about this in 1950 rather than 2020, then of course I'm going to want to squeeze every moment out of the current process of life that I can, even if it is under suboptimal conditions, even if it is in pain, even if I know how it will end.
Well, practically that's not true, right? I mean, if you go to an actual hospice where people are dying, That's generally not how it works, right? I mean, like, we tend to just shove people who are dying off into a corner and not look at them, and then they suffer a lot and die, and there's nothing they can do about it, and they can't really vote to fix their situation or even speak to complain about it. But death is not pretty in its actual practical situation. It doesn't really, if you could squeeze every bit of life and then you'd have the Hollywood death, then sure, but that's not what generally happens, right? If people who were dying could vote easily during their last bits of life, there would be no debate about euthanasia laws, I think.
I agree. It's a terrible process, but in my view, life in any state for the individual is superior to this absolute non-existence that we described. I did want to get to another question from Zach Richardson before we do closing remarks from our panelists. And he asks, what current efforts are underway to increase the efficacy of brain scanning devices so that we can in the future, quote, read the glutaraldehyde preserved brains? And I will supplement this question by bringing in David Wood's comment about the CT scans. He originally mentioned MRI scans, and it does seem like MRI scans can show more than CT scans. Can you envision some future non-destructive scanning technology for these glutaraldehyde preserved brains so that you could have an accurate 3D image taken of these brains and all of the synapses in them, but you don't have to slice the brain apart? And then you could create an upload. It might be a copy, but you would still have the original brain sitting there, essentially unaffected by some sort of non-destructive scan.
Okay, so there's a few parts to that question. One is Zeiss is working endlessly to make electron microscopes faster and better. They came out with a 93 beam.
He's asking about non-destructive.
Well, you asked both questions. How's the technology progressing, and then what about non-destructive, right?
Yes, feel free to answer both.
So, okay, if you want nanoscale imaging, though, the best things we got right now are electron microscopy and a very new technique called expansion microscopy. There's currently an NIH proposal, something along the lines of about $100 million to scan an entire mouse brain. One thing that I think is important to note here is electron microscopes aren't built like consumer devices, really. They're built more like Model Ts, in which you have some craftsmen that come together and they build like 12 scopes a year or 20 scopes a year or something like that. The moment you got serious about producing electron microscopes on an industrial scale, the price would decrease very substantially. There's no fundamental reason why you can't build an electron microscope just as good as the ones we use today for $30,000, about the cost of a car. In some ways, a car is harder to build than an electron microscope. Right now, Zeiss will charge you $10 million for an electron microscope, but the reason it costs $10 million is because they make like 12 of them a year and you're paying for a vast amount of engineering time for it, all right? So literally we could go from $10 million a scope to something like, let's say $30,000 a scope, just by doing them the same way that we do cars. And that would bring down the cost of scanning a human brain, which I estimate at approximately $1 trillion today, if you wanted to do it within 10 years with current technology. That would already reduce that, you got 10 to the 5, 10 to the 7. So like 100-fold-ish, 300-fold, right? So then it would only be $300 million? Is that right, Hayworth? Am I doing the math right on that?
Well, the electron microscopes are about $5 million a piece. I would say that there's a lot of hand waving in there. I want to reduce the amount of hand waving ever so slightly. There are people that are working on techniques that do reliable sectioning and ion milling so that you can get the types of really scaling up to these large volumes. So there are people that are working on this.
Now, if you wanted to scan a brain non-destructively at nanoscale resolution, like the only thing I know of that could even possibly do something like that would be like a huge X-ray machine. which in theory maybe could do it, but maybe would just melt the thing under any reasonable scanning conditions. And it'd be almost impossible to do, because what you're getting is like the convolution of the whole brain, like at every pixel. You have to somehow deconvolve it. It would be a mess. Like the computers to do
People
that.
have calculated this. The amount of energy that would be deposited would be, more than several atom bombs. It's
So then it takes forever to do. You just have to dump energy in. So in any case, economically, the destructive scanning techniques are almost always going to be cheaper and faster and better than the non-destructive ones, because you can expose a plane of material and then blast it with way more energy than you would otherwise. Same thing with expansion microscopy. You'd still have to probably slice, and also no one knows how to do that for a whole brain, but whatever.
But could we be at a point economically with these kinds of non-destructive scanning technologies that we might have been with regard to, say, decoding the human genome in the 1960s? That is, there could be future technological advances that would make it at first very expensive but feasible, and then more cost-effective at an exponential rate.
It could be, but then you're still going to have the destructive technologies first by, a lot. And so the question is it worth it to wait so long for a technology that may or may not ever exist? And also technologies are developed if they're useful, but if you're using the destructive ones, which is probably where we're going, why would you build the non-destructive ones, right?
Well, if you have philosophical reasons to build them, perhaps you will build them. Again, that underscores the importance of the discussion that we had, an unresolved discussion to be sure, but one that I think will need to continue within the community for the coming decades. But Ken, what did you want to say on this?
Well, I was just going to say that there are destructive technologies that exist today that can be extrapolated. And if you look at non-destructive technologies, there are simply zero that can be extrapolated to a whole human brain at the nanometer scale. That doesn't mean that they're not going to exist, but it definitely puts them in a different category of speculation.
Yes, and I would readily admit that it would be a challenging problem to solve. I just hope that somebody attempts it in the future. If we are going to have some of these preserved brains, it would seem to be a more, let's say, palatable way to get them to be uploaded, because then you still have the original for what it's worth, and then that original is a copy, but I'm less concerned about merely having a copy of an individual than about a process that destroys the original while making the copy, for reasons that we've discussed. But now I do want to bring in the other U.S. Transhumanist Party officers for their closing remarks. Art Ramon Garcia, what are your thoughts regarding this conversation?
Every time we have these conversations, and I ponder, would I do it if it were free? I think of the movie back in 1984 called Iceman, and that's where they found a Neanderthal who was frozen, and they unfroze him and they put him in an artificial habitat, and he tried to live his life, but eventually he found out he was in this artificial habitat. He broke out and just went crazy when he ran across all the technology. So I'm wondering if I ever had my brain uploaded and was woken up in this virtual world and discovered I was in this virtual world, would I want to break out of this world? And then if I broke out, would I go crazy because I just wouldn't be able to comprehend this future world?
So I can promise you'd be okay, because the worst case is you would have to go to kindergarten and you'd have to re-socialize and understand the society you're born in, just like everyone deals with when they're young. Well, when you were born, you didn't know anything about anything in the world and you had to learn it. So, I do think that any preservation has to not only include scanning and revival, but rehabilitation and educational opportunities. Because, it's going to be a huge deal, but you're going to be better equipped than some ignorant 5-year-old that's trying to grow up in the same society, right?
I mostly agree with what Robert said, but I would absolutely worry that some misguided future society might decide that it would be better to make a zoo of 21st century life. And I would find that absolutely not what I signed up for. What I would have signed up for, if I could sign up for such a thing, would be to continue my life as a full member of whatever future society. So yeah, I mean, I share your concern. Absolutely, I share your concern.
Okay, thank you both for coming. It's a lot to digest. Thank you.
Yes, indeed. And now let us go to Alexandria Black for your closing comments, questions, anything you want to pose.
I'm still wondering how much the field would open up if we switched from our sick care system to a real healthcare system. And one more second question, just how differently might our minds work as a positronic brain just because of the difference in substrates?
You know, people always talk about like, oh, maybe the brain's like a quantum computer or something, right? And that's nonsense. But I think it'd be wild to actually have a quantum computer and use algorithms that are an intrinsic part of your mind. It feels to me like that's gotta, you know, open up some cool things. But I mean, geez, like just having more working memory on its own, I think would be like more profound than putting on glasses. You know, if you couldn't see very well, I think it'd be huge. It'd be the type of thing where you couldn't even imagine living without it. I don't know. What do you think?
Well, I want to address this sick care. I mean, I absolutely, I'm horrified by the current medical system, whether or not it's as good as we can make it in some sense.
I don't think the chat people can see that. Can you maybe give a little bit of context on that?
Sorry?
Are you responding to the chat message?
Yeah, so the chat message and what Alex said in her question was with reference to sick care today being more profitable than healthcare.
Yeah, I can't actually read the chat either. So I just want to leave you with the idea that, you know, what if a substantial fraction of people really expected that that not only would they have the choice for brain preservation, but you know, thousands or millions of other individuals have already gone into brain preservation, and there is this this commitment from society that we will bring them back. We will bring them back, and we will make sure to take care of them because it will be our turn to be preserved, and we're all coming back together. What type of change that would release in society in general? I think that it would. I think that a lot of the problems that we have in this world today, maybe this is going too far, but I think a lot of the problems that we have in this world today are problems because people they know they're not going to be around for 100 years. They know they've got a short amount of time, and it's a zero-sum game at some level. And so, you know, I'm excited about the type of social change that brain preservation could, if it was widely adopted, create. I don't know if that addressed your question at all, but okay.
Yes, so it seems that Alex is satisfied with that answer. So now let's go to David Shoemaker. David, what are your closing observations regarding everything that has been discussed today?
First off, I'm wondering if I'm still me since we have started today's discussion, or if I'm a new me because of what I've learned and maybe new ideas that have come in, and did that change the essence of me? The rabbit hole of I-ness is quite interesting. But it's one that is worth discussing. I'll go on record as saying that I am a cryonics member myself, and have decided that in my particular case that it's worth spending the time and the money on something that gives me a possible solution greater than zero. I can't come up with any others. However, I am very interested in any new technologies, any new medical advancements that can improve on that. So I would love to see cryonics or what other industries that may come up this way, brain uploading, whatever they might be, not work at odds with each other, but actually try to find some common ground and work together. And then if you tie that to the healthcare system that we just talked about, that would be something that would be very dynamic going forward. So thank you for the new I-ness that you helped create in me today by seeding me with a few new ideas and on the ones that I currently have. So thanks for coming, gentlemen.
Thank you.
Yes, indeed. Thank you, David, for your comments. And next, we will go to Pavel Ilin. Now, Pavel, I don't know if you are directly present and able to ask a question or make a comment. I will read out a question of Pavel's from the chat. He asked, what do you think prevents cryonics and other brain fixation techniques from becoming a common practice? Is it a technology immaturity, or is there a management, communication, or cultural problem? And if, Pavel, you want to expand on that at all, feel free. Otherwise, we'll pose this question to our guests and then perhaps give you the opportunity to say something else later, closer to the very conclusion.
Well, I think above all, I would say it's a cultural problem.
Cultural problem, according to Ken. And Robert, do you agree with that statement?
Sorry, I was muted there for a sec.
Mm-hmm.
I guess, I mean, there's always this kind of way of seeing the world, cultural or scientific, right? You can't do anything without new technologies, but in a way, just science is everything, but you can't do anything without people behind it. So in a way, culture is everything. So, I mean, it's both sides of the same coin, right? But yeah, if society wanted to do brain preservation, there's no reason we couldn't have developed this in the 70s when we discovered glutaraldehyde and been doing it for the last 50 years. So sure.
So this is interesting. And to follow up on that, do you think the cultural obstacles are primarily that people simply cannot get their minds around any manner of persistence after the current legal definition of death, whether it be through cryonics or brain preservation or any other technique? Do you think it's the same cultural problem even that thwarts a lot of research investment into rejuvenation biotechnology so that many people might not have to die even within the current generations? Do you think it's just a lack of ability to conceive of a way of being that is very different from what humans are used to?
I feel like the nature of our society's opposition to dealing with death-related things is most akin to that of an abuse victim in an abusive relationship. And it's really sad. You know, you have this, people figure out they're going to die when they're kids and there's nothing you can do about it. And the psychic weight of dealing with that is so crushing that it's intolerable. So you are almost forced to have all these maladaptive ways of dealing with it. You either deny that death is real, which is not good for your ability to discern truth, or you deny that death is bad, which isn't very good for your ability to live life in an ethical way. And I would say most people do both because it's just so awful. You kind of have to do both, even though they don't even make sense together. And so I'd say that's where our policy comes from. And I would like to believe that if we do ever see the light on this, that you'll see a new type of humanity. If we didn't have to labor under this psychic weight of the inevitability of death, that we would be able to think more long-term and we'd be able to be nicer to each other. Maybe that's just wishful thinking on my part, but I really do believe that we'd see a humanity that would be unrecognizable if we ever really deal with this problem.
Let me just add one thing. I think in terms of the type of brain preservation that I'm talking about, it requires a depth of understanding in many different areas. If you're talking to a neuroscientist, they're not going to understand the computational level of the brain. If you're talking to a cognitive psychiatrist, they won't, a cognitive psychologist that may understand that, and where I-ness comes from. They won't understand what glutaraldehyde does. If you're talking to, there's a level of technology in the future that very few people understand that we're progressing to. And so, you could either ask that every single member of society somehow gets educated in all of these things, or you could demand at least that the educated, that the expert classes that are involved, which is the neuroscience community, let's say, that at least within themselves, they make it a point to understand all of these issues, and then are able to say, yes, this is something that we can essentially put our stamp of approval on. Because if you imagine it, people get LASIK surgery and they don't have to understand every single aspect of how a LASIK surgery operates. They probably would prefer not to. But they know that there's some experts that have really looked into this and have said, yes, that this makes sense. We need this type of discussion within this expert class. And then the question is, why isn't that happening within the expert class? And that is something that I really struggle with, and I feel like it might be that. Well, I hate to say it, I think there's a lot of people within, let's say, the neuroscience community that hold out borderline mystical ideas about how the brain works. It's like an open secret. But there's some people that would probably look at that I-ness thing that you're saying, and unlike me, that just says, well, look, that doesn't make any sense from a computational perspective. We've narrowed, we looked at the phenomenon. We know why people think that they have this I-ness thing, and we tied that down at the computational level. That's where it would exist. There probably are many neuroscientists that would completely agree with you that, hey, this I-ness must exist in some molecule that we haven't discovered yet, which is completely incoherent, but they would probably say this. So we've got our work cut out for us. If you look at religion, let's say, they're saying, just believe that you're going to go to heaven, and you're going to go to heaven. Man, that is as easy as you can get. And you compare that to the kind of super hard work that you have to do in this respect. You don't get immediate gratification. It's like 200 years from now, luckily, if you're lucky, you get revived. If you're not basing this on real facts and reasoning, then people are just going to dismiss this because it's too hard. It's too hard to think about. It's too hard to do. Let's just go with the with religion.
With the sure thing.
With the sure thing, absolutely.
Well, thank you both, Robert and Ken, for your remarks. And I agree with Robert that attitudes toward death are completely dysfunctional in the mainstream society, and the many techniques that people have adapted essentially to their fear of death and trying to minimize the fear of death through some form of death acceptance are understandable coping mechanisms, but they're profoundly counterproductive in trying to do something about this problem. Alexandria Black remarked, won't we seem unevolved to those future people who never dealt with the dystopian inevitability of death? And I would say yes, because those future people won't have the same, let's say, rationalizations or mental contortions that a lot of our contemporaries go through to try to justify this unfortunate predicament. There's even a concept of terror management theory, which attempts to explain a lot of human activity as a way of coping with death, but that has many deleterious side effects. Now, with regard to what Ken said, I would tend to agree that within many scientific communities today, there are some suboptimal dynamics. Aubrey de Grey has talked about this at depth with regard to why some scientists are reluctant, even if they theoretically might agree with the premises of longevity research or the SENS approach or rejuvenation biotechnology, they would not devote serious research efforts to those areas. And a lot of that has to do with pressures from the bodies that distribute funding, what is considered to be prestigious in one's particular career field. Essentially, how is one likely to make a living without becoming an outcast? And there's a lot of work to be done in changing those kinds of mindsets, especially if there are a lot of government programs that tend to award grants based on fairly conservative criteria because they don't want to be seen as misusing taxpayer funds by investing in overly risky ventures. So all of these are issues to overcome. But of course, Ken, I do think those neuroscientists who give some credence to the idea of I-ness in one form or another are onto something. There is something real that we experience in our subjective awareness. And I don't think it can be merely reduced to computation. Now, I don't think it's a single molecule. I think it's the sum total of the processes that comprise our conscious awareness and functioning. It's like you can have a heap of wood pieces in various shapes, and just in the heap, they're pieces of wood. You can't do very much with them. They have all the properties of pieces of wood. But if you assemble them into a chair, you have a unique property now called chairness, which enables one to do interesting things with that new object that you can't do with the heap of wood.
Yes, exactly. The way that you get a chair from a wood is exactly how consciousness is made from biological matter. That's exactly right. Mm-hmm. But it doesn't require there to be some sort of metaphysical chairness that's attached to the wood.
Well, the chairness is a description. It's a new property. It's a description of what that thing is able to do, what purposes that thing is able to serve, that the pieces of wood wouldn't have been able to. And this is a very Aristotelian view, I admit. So Aristotle differed from Plato in that he didn't see abstract forms residing in some other ethereal realm. And a lot of people of a more mystical persuasion are actually Platonists in one sense or another. Aristotle saw these essential properties of objects as residing in the objects themselves. So the chairness is a property of the chair. If you destroy the chair, there's no more chairness. There's no abstract form of chairness that survives the existence of the chair or every chair in the universe. But in any event, I wanted also to get to Dan Elton. Dan, since you organized this salon, what are your impressions of it? I know we've spoken now for more than 3.5 hours.
Yeah, I had a feeling this was going to go long. That's why I was, for the sake of our audience and everyone involved, I was trying to constrain it up front a bit. But I think despite it going long, I think it turned out really well. I really enjoyed the back and forth between, especially between Robert and Gennady. Even though it was took a while, I think that the thought experiments. So the way that Robert argued, so I generally agree with Robert. And that essentially just and Ken, that the memories are the core of identity and such. But and the way that Robert argued against Gennady is very different than how I was going to argue against it. So it was very interesting. We didn't really get into, now there's so many different philosophical issues here. I think maybe that's part of the reason people have trouble. There's just so many, there's all, we didn't really even get into consciousness, right? So one of my concerns with uploading, I fully support all the work that you guys are doing. I think we need to, but one of my concerns is that in the future, we may be doing uploading, and then we're going to have these uploaded versions that appear to be perfect emulations, but they're not actually conscious. And so that's the problem of like philosophical zombies, right? So we didn't actually get into that. And but that really, basically, the only way we're going to solve that is by understanding the mechanism of consciousness and making sure it's being replicated, I think.
I completely agree with you.
Yeah.
We need to understand consciousness at a scientific level. And everything else.
Right. And I wonder if some people just, if the reason some neuroscientists don't want to be, endorsing brain preservation and uploading is because they don't want to sound overly like they understand consciousness. Like everyone agrees we don't understand consciousness, but if future, what all you're saying is that people should have be allowed to undergo this procedure, right? And also, I think when you are able to demonstrate it, that will have some power.
I agree. I'm very briefly. I'm saying something a little bit differently. I'm saying that people should definitely have the choice to do something if it agrees with our best scientific knowledge today. Mm-hmm. And the idea that that there might be some radically different, that we were so wrong that we need to take away a choice of possible life from terminal patients based on the possibility that we might be radically wrong just seems out of the question. But I agree. I mean, neuroscientists do not want to make broad statements about that make it seem like they understand how the brain works and that we're on threshold of upload.
Yeah. We just need a lot. Right. So there's still a lot more we didn't get into, but I really thought it was a great discussion today.
Yes, indeed. And I would welcome continued exploration of these questions, both with regard to consciousness and I-ness and what view of identity is more accurate, whether it's the pattern view or the process view. I've had an impromptu debate about this with Ben Goertzel as well at Bradfest in 2019. It was actually close to midnight, so probably if it had occurred at a different time, we would have been able to go into far greater depth. But he's also a patternist in the sense that he doesn't have a problem with having multiple copies of himself. He doesn't have a problem with stepping into the Star Trek teleporter, whereas I would, because deconstructing myself atom by atom and reassembling myself would seem to be that kind of discontinuity that I would be averse to. There was an episode of Star Trek which was quite interesting, where Commander William Riker stepped into a teleporter, and then there was some sort of accident where another Riker actually materialized, Thomas Riker, and then he came back after a few years after having had his own experiences. This is in Star Trek The Next Generation. This is one of those scenarios to be wary of with that kind of transportation technology.
And he became
I
a
think
fighter
sci-fi
pilot and stole his girlfriend too.
help people think about these things, and that's actually good. Like, people need to wrap their head around this concept. It is a little hard to wrap your head around first exposure, certainly.
Yes, indeed. And then Pavel writes in the chat, "Thank you, Ken and Robert. This was one of the best broadcasts we had. Even after just listening, my brain is boiling a bit." And this is the kind of hard science conversations we need in order to get not to magical worlds, but to the transhuman future, which is actually possible. So thank you, Pavel, for those remarks. And now, as is our custom, we will let our guests have the last words for this virtual enlightenment salon. So whoever wants to go first, if you'd like to share some concluding thoughts about this discussion, or where in the future it could be taken further.
Well, I'll go first, Robert. I just want to thank everybody for inviting us on this, and thanks for keeping an open mind. So thank you very much.
Yes, indeed. Thank you, Ken, for partaking in this and for all of your insights today. And Robert, what are your concluding thoughts?
Fantastic people. It's been a wonderful conversation. Definitely will be open to talking about it in some other form, whatever is appropriate. And I guess, right now we've got a great opportunity that's better than the previous generations have had, that it seems like we're very much on the way towards having a fully validated brain preservation protocol. And what I encourage everyone to do is just think about your assumptions and why you believe them. And almost always it's more complex and kind of inscrutable than you think that it is. But the odds that you happen to be right and that your intuition happens to be right on a lot of things, what is common sense other than just common, right? Maybe we need some more refined sense here. But yeah, it's been great.
Yes, indeed. Systematic exploration of these kinds of questions is what the virtual enlightenment salon format seeks to foster. And I'm pleased that we've been able to have such a lively discussion delving into so many areas of neuroscience, life extension, cryonics, brain preservation, as well as philosophy, because philosophy is crucial in addressing these questions. And hopefully our audience learned a lot from this conversation. Hopefully we've given you ample food for thought, but please keep thinking about these issues and come up with your own ideas and your own understandings. We will be back next week for another virtual enlightenment salon. It will be on Sunday. The time is yet to be announced because Fest is also next weekend from October 2nd to October 4th. So if you're interested in some of the leading thinking on radical life extension and emerging research in the area, check out RadFest. We will try to schedule our salon not to overlap with that event. So in the meantime, thank you to everyone who stayed on for this salon. Thank you to our guests, Ken Hayworth and Robert McIntyre. Thank you to the U.S. Transhumanist Party officers, and live long and prosper.